All right, I think it's time to begin here. I want to see some people are still dialing in, but there's a few just logistics and orientation things. So first of all, I wanted to say thanks to everybody that's on the call out there in YouTube Live Land or also on Microsoft Teams here with us, being able to participate in our overall agenda here today. Got a few hours with everybody. Then definitely a special thanks to all of our international panelists and speakers. We realized it's pretty impossible to pick a perfect time for a virtual meeting like this one across a full set of international participants. Typically, maybe this would be done in person, and we'd let people travel and be a little bit easier on everybody time-wise. For reference, in Singapore, it's 1:30, in Korea, it's 2:30 in the morning. So it's not today, and it's definitely during a time when they would be sleeping. But it's a very convenient time for us. I think it's a really much needed meeting that we needed to host. Anna over at NARI, PK, Lexi Brown on our team, a lot of coordination went into this meeting, so I want to give a special thanks to them as well. As far as the timing of the meeting, one of the reasons I could tell that the urgency was growing overall to host a meeting like this is just day-to-day basis. My level of interactions and work on international is growing. Each week it's more and more and it's more. If it's not a question about demonstrations happening here in the US or applications for permitting and things like that in the US, working ICAO issues or other working group issues, reciprocity, regulatory things, coordination across standards bodies like RTCA and EuroK, different partners that we're working with on national campaign and across our research portfolio. So just in general, I know here from a U.S. domestic perspective, there's just a lot of interest in international, a lot of stuff happening. That having this meeting now was timely, and it gives us a way to, something to work towards over the next year, when we can get back together in person and start really collaborating with everybody even more formally. With that, I'd like to move to the next slide. Just a small orientation about, our AAWG, AAM ecosystem working groups and what we're trying to accomplish. Just to, point you guys again to rationale for why we're here. At the bottom of the slide under the graphic, you see form a connected stakeholder community. That's something I think we've done a great job with our AAWG. I know for me as panelists on different sessions and, leading different sessions and such, having the people that we bring together to host these meetings and the conversations that we have on these meetings has introduced me to a lot of new people. And I know people within our team to a lot of other new people that are really helping us accomplish our overall initiatives at NASA. Looking at some of the other objectives that we have, align on a common vision for UAM. I think, today's meeting is going to help us a lot towards that. Collectively identify and investigate key hurdles and associated needs. The international perspective there is huge. It's really important for us and everybody internationally to have a common message and understand those hurdles and how we need to solve them together. NASA has critical commitments around building AAM system and architecture requirements. That coupled with the regulatory and standard support, I think we need to generate something for our commitments to our domestic industry that is internationally accepted as much as possible, and it gives our industry the confidence to move out and know that they can, sell aircraft and systems and partner with international across the globe. So that's just a short orientation. Move into the agenda real quick, please, Lexi. Really great day planned. Like I said, a lot of great work went into planning this agenda and organizing all the speakers. Start off with a short introduction from me. We'll turn it over to our international representative, Justin Tillman, to say a few words. Then go over to PK, where he'll talk about the goals and objectives for the day, give some international perspective there, and then I'll give a short NASA brief that is similar to the next series of briefs that you'll get. You'll get to see where NASA's working and kind of some of our international perspective, verbally mostly, but some slides that point you towards it. And then we'll move into individual countries, 10 minutes each, to show you what they have going on, some of the really interesting things. I'm privy to a lot of it. Some of them will be new to me as well. So I think it's the ones that I know what will be specifically talked about and the activities they have going on. There's really great stuff that I think everybody should be interested in. Next slide, please. A little bit more of the international at the top of this one. Then we'll have a panel on international standards and harmonization. Had a pre-panel meeting about a week ago. Really great discussion happened at that meeting, and I expect that same thing to happen here today. A lot of good information for everybody, good insight into what's going on from an international regulatory and standards perspective. And then PK is going to host an open discussion where we'll have 40 minutes. We'll be taking questions from Conference IO and then here live on Teams. So PK will host that, and then we'll go into some closing remarks. And hopefully by the end of the day, we'll have a lot of good insights into things and actions for us to take at NASA moving forward. And I'm sure there will be a lot of connections made behind the scenes that we don't see. So with that, again, thanks to the NARI team for putting this together. Thanks to everybody on the phone, especially the international people that should be sleeping right now, but we really appreciate it, and I'm really, really excited about the next few hours. So with that, I'm going to turn it over to Jess. Oh yeah, sorry, Anna, go ahead. If you could do some logistics.
No worries, thanks, Davis, and welcome everyone. We're excited to have you all. Some of you have participated in ecosystem working group meetings before. For those of you, this is a gentle reminder. For those that are new to us, this is a little bit about what to expect in terms of how we dive into the discussion. So there's two types of participation. One is active participants. That is all of you that are here in the Microsoft Teams meeting room with us. So for this first portion, all the way up to the panel, you'll mostly be in listen mode, but you'll have the opportunity to type comments, questions into the MS Teams chat here. We do ask throughout your time here, you leave your cameras and webcams off, and you do remain on mute unless you are speaking. You will have an opportunity to speak in that last 40 minutes discussion section that Davis just mentioned, and we encourage you to use your raise your hand and microphone at that point. And PK will call on you accordingly to kind of really create a robust discussion at that point. That being said, we do recommend you entering comments in the chat throughout the whole meeting time today. Meet each other, dive in, and that will be recorded and saved to share with speakers and everyone involved as applicable. If you are selected to raise your hand and speak during the discussion, please say your name and affiliation before you dive in. That's just meant to allow us to have a little context to your comments and be able to continue the conversation forward. So the other group of you are listen-only participants. You are watching now on a YouTube live stream. You can access that at the AEWG portal, and that link is here on the page. For all of you, we still want you to contribute and ask your questions, so you'll be able to do that through Conferences IO. There's a short link here on the screen as well, and just select the International AAM Day, and that will allow you to find the specific session for this event. That link is also in your YouTube meeting chat, just to make it as easy as possible for you to jump over. We do again encourage you to enter questions throughout the event, but they will be addressed in the discussion portion. PK will pull them in throughout that discussion. So again, thank you all for coming, and I am going to pass it back to Davis to introduce Justin.
Yeah, so Justin, I'll be brief here, but yeah, aeronautics lead for our agency in international and interagency relations. My first introduction to Justin was on a trip over to the UK just about a year and a half ago now, I think, and I knew pretty quickly that Justin was a good person to stay in contact, keep me in line, if you will, from an international perspective. He's invaluable to our AAM organization now with what he's helping us with from an international partnership strategy perspective. Does great job for us at tracking what we have to do moving forward, helping us harmonize with our partners and generate next steps, document things, and really create the partnership dynamic that we want at NASA. So with that, John, thanks, and looking forward to what you have to say here.
Yeah, well, thank you, Davis, and I appreciate the introduction, and to Anna for getting us all organized here today, and echo the welcome to colleagues around the world and to those here in the United States. I'm really looking forward to the conversation and the learning that will happen today. Just a few words perhaps about NASA's international perspective. So we're the National Aeronautics and Space Administration for the United States government. We focus on scientific and aeronautics research and engineering. And from an international perspective, we work with over 130 countries around the world. We currently have more than 600 international agreements with partners around the world, primarily focused on very specific projects in science and engineering. Within our Aeronautics Research Mission Directorate, examples might be work around the world on supersonic standards, or in the research and development related to air traffic management. And this is, from my perspective, an exciting new topic with all of the participants here today. What we find in this emerging area is part of NASA's effort is to try and scope the problem and build projects around the challenges. And that is in part, of course, must be done in concert with our international partners and with input from around the world. So very much looking forward to that. In terms of the way that NASA might approach international partnership, as the U.S. government organization responsible for space and aeronautics research, most commonly our partners around the world will be other government research organizations. We also will work with industry, for example, through our Advanced Air Mobility national campaigns. And then often we'll start through information gathering, sharing information, gathering inputs, and that is in large part what we're focused on today. So again, we welcome participation, views, and look forward to a continuing dialogue on this important topic. So with that, I'll turn it over to PK, who is the director of the NASA Aeronautics Research Institute, NARI. So PK, over to you.
Great. Thank you all again for being part of this interesting day. And this is the beginning. We are just starting international discussions early. One of the lessons we learned in prior work related to drones is that we want to understand the international concerns as well as considerations are really early stage, so that we don't end up getting into the same situation like it happened with cars. When some cars drive left, some cars drive right. We want to try to harmonize as soon as practical, as well as leverage each other's work. So there is no reason to duplicate things that other people have done or we have done that can be shared freely. I think the goal is really to truly build a community of interest as a global partner. So next slide, please. So the big picture thinking here is I think we are at the intersection of technological advances that could potentially transform the whole society. One of the sayings is that 1 mile of surface transportation road or a rail can take you only 1 mile, one way, this way and coming back. But if you have an aviation land that's 1 mile, you could use that to go anywhere. And that's the true power that we want to basically exploit and make sure that the benefit of aviation can be seen and accrued and experienced by the entire globe, because it does bring societies together. It does increase the standard of living. It does help connect things better, and people can live wherever they want to live and work wherever they want to do, and then transportation comes to you. Instead, what happens today is where you had to basically live close to the highways or railroad or metro so that you have access to transportation, and the businesses get located closer to the transportation hubs, and so all businesses get conglomerated into the central business districts, and adds to congestion and so on and so forth. So aviation has that ability to unleash or unlock that gridlock for future, and then much more distributed living and businesses and greener landscapes are possible because of that. Next slide, please. So really, and that's only possible because of the electric propulsion. In the past, it's not that there wasn't urban air mobility, advanced air mobility. 1948 and 1952, there was New York Airways and Los Angeles Airways. And they had their own moments of glory, but they failed for a number of reasons, but safety and the noise and the cost. But now with increased technological advances, particularly electric propulsion, and the smaller, basically hardware stacks, we are able to use that power of transportation and connect into the different locations, whether it's drones for deliveries or surveillance or information gathering, or electric vertical takeoff and landing vehicles, or even the short takeoff and landing vehicles that will leverage existing airports. Now we can actually now have a much more integrated air transportation, and the dream is to see that air transportation reaches every zip code some way or shape, whether through drones or through vertical takeoff and landing vehicles and such. In order to get there, it needs to be acceptable by people in terms of the safety and noise and other aspects that are critical for good standard of living. And that's where we are really focused on research, to try to, how do we bring this society together by connecting these, but yet allow you to stay and distribute the living spaces and businesses so that we're not all congested at the same location. So transportation comes to you rather than you start living or locating yourself close to the transportation hubs. That's sort of the big ideas here. Next slide, please. And just to sort of give you a perspective of that, last couple of semesters, we basically did some student intern projects, and we connected the farmers with food bank through aviation. So in the summer, during the height of the COVID, we basically experienced that farmers were throwing away food, fruits and vegetables, because there wasn't enough labor available to take that and transport it to where they would need it to transport. At the same time, the food banks were on overdrive. So we connected our student interns, kind of build a portal, connected basically the farmers and the food banks, and got some volunteer for basically flights through Angel Flight and pilots, and we had 30-some deliveries, 30-some flights made deliveries. We repeated that again. So that was in California. And then we repeated that experiment again just before New Year's in the New Mexico with Zuni tribe, where we delivered 1 ton of supplies to one of the tribes where it wasn't possible to reach by road. So it was interesting experience that opened my personal eyes to say, what is the true unleashed power of this aviation that can transform the societies by basically pulling these things together and have goods and supplies available as possible. And if the closer we bring them these services and support and transportation to people, the better they will be able to live and enjoy the lifestyle that everybody deserves to. So that's sort of the true power, and where we want to see this go is to that we really would like to harmonize some of these things in terms of the airspace operations related concepts, in terms of the vehicles and the noise standards, so that we know people will have less basically nuisances based on the aviation coming there, and a lot of reservations about that. Also the safety protocols. Safety is an international need. Safety doesn't belong to one country or other. We need to make sure that the transportation system that we put together at large has safety built into that, and the methods that we will be building and the technologies that will assure safety should be available to entire globe. And that's sort of the idea, is we learn from each other what things you are doing, what things we're doing, and how best we can leverage those things. So we have a number of priorities, of course, in terms of aircraft design and making sure that the aircraft operates in the conditions where there could be no GPS or stressed GPS, and acceptance of vehicles based on the low noise. What are those standards and requirements and people's perceptions? Safety is one big area, air transportation and integration with air traffic management, as well as automated systems through digitization that will connect, are all good areas where we see a good bit of harmonization. There would be some obviously local considerations at the regional level in terms of the zoning requirements and fire codes and access to the surface transportation. So those will definitely have to be considered at the localities level. Even inside each country, they could be different, but at aggregate level, there will be some key themes where we would look to harmonize some of these constructs. Next slide, please. Yeah, so the goals and objectives that we have for basically working together in collaboration with you all, as well as the entire industry, is that we have set up this advanced air mobility ecosystem working groups. These working groups are considered global resource. Everybody is welcome to participate. Everybody is welcome to contribute. Everybody is welcome to learn, share, and care about each other and ideas. The goal is to try to make sure that we collectively move forward. And we have developed something called industry scorecard. We have developed something called urban air mobility maturity levels, so that we can make progress on the aircraft, airspace, and infrastructure side. So please participate in all those working groups. Those working groups are available, accessible through NARI website. But we also want to understand, any interesting things that the international needs that you may have that needs to be considered at large, because the vehicles that get manufactured in one country will operate in another. Maintenance is another area. This maintenance will be very much localized operation, but at the same time, they need to be consistent and basically efficient across the globe. So the idea is to try to harmonize as many things as possible. In terms of this system architecture and requirements, so that we may have some data standards to connect into air traffic management. We may have data standards to share information about the maintenance or part provenances and things like that. All of those could be really useful if we collectively work on it, and then I understand any policy or standard gaps that may be needed that will cover the entire gamut. Next slide, please. And that was my last slide, and thank you again for being part of this. And we are really very much looking forward to this. Is as much as NASA sharing, as much as NASA learning from you all. So please feel free to share your perspectives and your unique needs, or any ideas that need to be basically considered for harmonization. As I mentioned, airspace, aircraft itself, the characteristics of the aircraft operations and the safety. Those are very critical, and generally the basically progress and learning from what you have basically been exploring and what we have been exploring, so that we avoid duplication and make sure that our resources are utilized as efficiently as possible across the globe. So thank you again for being part of it, and I'm going to hand it back to our AAM Mission Integration Manager, Davis Hackenberg.
Thanks, PK. And Lexi, if you don't mind, just advancing to the next slide, please. I think many of you out there have kind of seen our NASA pitch overall and what we're trying to do with respect to advanced air mobility and how urban air mobility fits into that. But I'm just going to provide a quick orientation here and try to be done by 1:05, which is my set time. Spoke a little too long at the beginning, I think. Advanced air mobility mission overall, I think many of you probably remember just a couple of years ago, we were talking more focused about urban air mobility. Advanced air mobility seemed to be the right context for us really overall. The eVTOLs that are being built and urban air mobility is really, the kind of ultimate use case within advanced air mobility. It's a more localized use case is the way we define it. But there is this regional, intra-regional perspective, moving people from rural areas into the outskirts of cities and anything within a local perspective from rural. So we've changed to advanced air mobility, and what we found really is from an international perspective, there's definitely a huge UAM focus. But there's also some countries out there and then obviously use cases and missions even here domestically that are much more AAM focused. And what we want to do is be able to harmonize all of this and create a regulatory framework and standards that allow all of these industries to take off. One of the important things that I think about our advanced air mobility mission is the progression that we plan to go through. We'll talk a little bit more about that from a national campaign perspective and everything. But if we really want to get to the automated systems we talk about, it's not all going to happen in one chunk. A progression like this, like we have laid out with our UAM maturity levels, also helps us kind of show how we work with different industry partners based off of their configurations and the automation vector they plan to take, whether it's early piloted operations for UAM or short-term cargo carrying operations for small to mid-size UAS, or even long-term remotely piloted end-to-end concepts for passenger carrying UAM. So our UMLs are used for that. There's a lot of information on them online. If you're not familiar with them, please go take a look. Otherwise, this slide just gives you some representative use cases that we look at as aligned with each of those progressive UMLs that we'll build out through our national campaign series. Next slide, please. This is domestic and specific, obviously, shows you some of our leaders here domestically, not all of them by any means. This isn't a comprehensive slide, but we're pretty proud of what we have here domestically. At NASA, we have a great set of partners represented across this slide as well. We also recognize that you could develop this in many cases for each individual country. There's a lot of UAM players out there right now, a lot of designs. And really, if you go by continent, there's viable players on each continent, I think. And so everybody could build this out individually, and we're excited about that. And we also, keep that perspective that we know our companies are going to want to sell internationally, and the international companies are going to want to sell domestically here. So this slide's just to remind everybody how real this industry is, and hopefully each of you have something similar, that a set of partners that influences from your government or industry perspective, a set of partners internationally that influences where you're going. Next slide, please. General overview of our partnership strategy at NASA. For some context, really three major prongs we talk about in our partnership strategy. The first is the top one, identified in red and blue there. Really points back to our vehicle and airspace partnerships, traditional areas that NASA develops technologies, capabilities, requirements, and such. Working with our regulator is something that I think, internationally, we are as strong as any other R&D agency. We have really strong ties to the FAA, individual processes with them that we go through to build ConOps, develop technologies with our partners, and get regulation behind them. There's a lot more to it in these new emerging markets, though. We realize how important in our country's geographical representation, how important our states and localities are, how important international is to that, and standards bodies as well. We work directly with them in our research portfolio, but there's also a larger set of standards bodies and organizations that UAM, AAM brings to the table. So we've partially set up this AAM working group, as you saw previously on my intro slides, to help us communicate and form a connected stakeholder community across them. We continue to leverage national campaign as our centerpiece, where we bring all of our internal research and development activities together. Not all, but many as relevant of our internal research and development activities together, as well as work with our partners to host operational demonstrations and flight campaigns that really push the regulatory processes as well. It shows that the technologies we developed are accepted and implementable by our regulator and safe operational scenarios to progress this industry. So that three-prong approach is represented here. Next slide, please. Just go through this animation if you don't mind. Sorry, I keep meaning to remove it. Overall, we talked about on that orientation slide as well for the ecosystem working groups about our critical commitment, deliver aircraft, airspace, and infrastructure system and architecture requirements. Overall is what we're focused on. We're leveraging MBSE to kind of corral all of that and have a real comprehensive understanding across all things in this very, very complicated ecosystem, what we're going to do. One of the most important things with our MBSE long term is validating the products that we have, the inputs into our MBSE, the requirements that we've developed and our partners and standards bodies and everybody has developed as a comprehensive set that works domestically and internationally. So you'll see that this whole critical commitment area is a focus of our ecosystem working groups. It's also a focus of this international type of concept. This is where we will, I think, in its most technical level, represent that harmonization. Next slide, please. These are some of our technical areas. We call these our mission priorities. They're also representative of L1 requirements that we manage to internal. We also call these areas technical challenge sometimes. So there's a little bit of internal code words you'll hear around these, but these are the focus areas of NASA. This is what most of our money and resources, personnel are going into. Most of our partnerships are centered around. Each one of these has individual partners as well as common partners across them. And really each one of the major pillars, and sometimes even down to the specific priority level, has a different international strategy associated with it. So I can't explain all that to you here in one common slide, but what we are looking at is from an organizational perspective, R&D organizations, government organizations specifically, from an international perspective that will help us advance this agenda overall. And then we will always have our individual technology or capability area needs that we look for international partnerships on. Next slide, please. This is a representation of our national campaign progression. So it's loosely based off of what we did in our the concept of our technology capability levels that UTM implemented. We know this is a long road, 10 years. It's a long time to plan for. We think that's what we need to plan for, a 10-year plan to get to automated AAM. We really want to push at NASA the scalability component of it. We don't particularly like the it's for the rich connotation that comes with this sometimes, and we believe that there is a long-term plan to get to automation and get the price points that the general public, middle class at minimum, will be able to use and fly these and have it benefit society overall. And then, like PK said, we believe these configurations have opportunities across the board for all kinds of unique missions to remote areas. Alaska in the United States here is a really great example where there's cities that are completely disconnected from the grid and roads, and they need aircraft to take them food, supplies, milk, diapers, things like that all the time. So we look at this national campaign progression as a way to get us to scalability, and it's a way to work incrementally with the industry along the way based off of whatever their use cases and automation vectors are. Next slide, please. And then getting a little bit specific on the national campaign here. We have worked internationally with some specific partners. I'm not going to name them here today because we don't have any agreements in place yet. But leveraging this AEWG concept, we've been able to provide briefings like this and many times in more detail with a lot of discussion and Q&A on them. And what we've seen is some countries actually being able to come to us and propose back activities to jointly work with NASA in the language we speak, pun intended, but in the national campaign language we speak based off of our objectives, specific areas that their country's progression is working through, flight demonstrations, technology, that they can speak to us and talk about different areas where they can contribute, and we can leverage national campaign as a major activity for international harmonization. Going through them real quick, scenarios and use cases. Many of them will be common across, specific to urban air mobility, across any international partner that we work with, but the specifics and the considerations for those use cases and what might need to be done can be different country to country. We want to make sure they're harmonized as much as possible across the globe. Data elements and models. Our data national campaign is built as a massive data collection activity, as well as the operational part, pushing through the acceptance on the FAA policy and standards piece. But really to generate, comprehensive standards that are internationally harmonized and domestically harmonized, even, which is a challenge in itself. We want to create a robust, consistent data collection activity, and National Campaign serves as that. And then those flight demonstrations, obviously, they're the bread and butter. They're what most people see. They're the emphasis of where we're going. So with that, those are some of our partnership opportunities. Looking forward to continuing this conversation as we move forward. But with that, I'll turn it back over to Anna for logistics. Thank you.
Yeah, thank you, Davis. We did schedule a 10-minute break here. We're going to go into the 8 UAM, AAM country updates after this. So we want to give everyone a chance to just quickly grab another beverage to settle in for the awesome information coming up soon. So with that, we'll see everyone in 10 minutes.
Well, welcome back, everyone. Hope everybody was able to take a quick break and get settled in for the next session. Very much looking forward to this. In the last session, NASA provided a brief overview of our plans, projects, and interests going forward. And in this next session, we'll hear from a few organizations around the world about some of their projects and plans in UAM, urban air mobility, and UAS. So I will start with a very northern latitude perspective. We'll introduce Duff and from the Canadian perspective. So Duff Gowanlock is a qualified flight test engineer at the Flight Research Laboratory, National Research Council of Canada. So Duff, over to you.
Oh, many thanks, Justin. I'll just share my slides here. Hopefully that's coming through all right.
Looks great.
Awesome, thank you. So yeah, thanks so much, Justin, and greetings from snowy Ottawa, Canada. We're just coming out of hopefully the last grips of an icy polar vortex. Hopefully, looking forward to spring weather and hopefully increased vaccination in the end of COVID, so we can meet in person hopefully the next time around. So it's a real pleasure to be able to talk a little bit about what's going on at NRC and in Canada around the advanced aerial mobility domain, and specifically some of our research activities. But first, I just wanted to say thanks to Davis, Justin, PK, Lexi, Anna, and everybody else at NASA for their leadership in putting together today's session. I'm really looking forward to hearing everybody's presentations and discussions. And I think in the as PK said, in the AAM context, the world's really small, and collaboration and alignment will absolutely be key to success for everybody. So 10 minutes isn't a lot of time to talk about what's sort of going on north of the U.S. border up in Canada. So I'll just sort of hit a bit of the wave tops. I'll start off briefly talking about the NRC for those that aren't familiar with us. I'll talk briefly then about some of the Canadian unique factors around AAM, and then discuss just a couple of slides on our research activities. For those that don't know us, the NRC is Canada's largest federal R&D organization. We have three main goals, as you can see on the slide. And our technology focus sort of covers the gambit, from everything from human health therapeutics to astrophysics to aerospace, of course. And I myself, I'm part of the Aerospace Research Center. And we fundamentally focus on 5 aerospace domains, looking at aerodynamics, manufacturing, flight research, structures of materials, and propulsion. Yeah, and so in terms of the Canadian context, AAM, of course, is translatable across any country, but each country has its own unique challenges. And so Canada is one of the largest countries in the world, as I'm sure everybody's aware, but we have a very small population, around 36 million people, and that puts us at a ranking of 122 out of 233 countries in terms of population density. And so the picture on the left there, sort of the yellow, orange, and red, sort of show where our population density is arrayed. Uniquely, 80% of our population is within 160 kilometers of the border with the United States. And on days when it was cold like it was yesterday, minus 30, I think people even want to go even further south to get away from it. But paradoxically, mixed with that population density, we have a number of communities and localities in Canada where there isn't infrastructure to support road access. And so the picture on the top right, you see the red dots are communities where there's only air access, and then the blue dots where there's a combination of air and seasonal roads, so winter roads, that sort of thing. And so a context that's ripe for AAM applications. But within this context, and especially when we look at the population density along the southern border, we also boast, and I'm not sure if it's something that you boast, but we have some of the busiest roadways and one of the busiest roadways in North America, and we have some of the same population density challenges that are common across many nations. So again, very applicable for AAM technology applications. So it's with this backdrop that we've established our research program at the National Research Council called Integrated Aerial Mobility. You can see the goal here is to create an ecosystem within Canada's industrial capability for the global AAM market. We focus on mainly three aspects: advanced niche technologies, especially those where we have Canadian strengths or unique Canadian applications or considerations, as well as supporting a stronger supply chain, and for sure supporting regulatory development of the regulatory framework. And so in terms of our application spectrum, we focus on everything from small drones to large cargo eVTOLs and up to air taxis within this program. We specifically focus, as sort of depicted here, on surfaces, cargo, and people primarily, but we also have a vector or an application that also looks at security and defense considerations for the technology. And so the program itself is broken down into two large innovation domains, so vehicles and operations. And then each domain has a series of master projects and technology building blocks. And so, the program is really complex, and I obviously just we'll touch on the wave tops, but welcome questions, follow-on discussions, getting linked up afterwards as appropriate. From the vehicle domain perspective, we have two master projects, as you can see here: integrated design, which consists of low noise technologies, so looking at technologies to reduce noise from eVTOLs, as well as measuring technologies around measuring noise emissions. And then second, technology building block that looks at airworthy and crashworthy structures, focusing on design, materials, manufacturing, technologies, that sort of thing. The other master project that we have within the vehicle domain is the operating environment. And so anybody that's experienced a Canadian winter certainly probably understands some of the unique considerations around weather tolerance, icing considerations, those sorts of things. So we have a dedicated technology focus around that. On the far right, on the bottom picture there in the right bottom corner, we also have a technology focus on urban integration, specifically looking at aerodynamics, turbulence, gust rejection, noise, and other properties of specific interest for urban applications. Finally, in the middle bubble, we also have a research expertise and capability focusing on impact assessments, looking at small UAS impacting aircraft, manned aviation, as well as humans. On the first hand, the picture here shows some of the testing we've recently done with small drones impacting aircraft structure. Obviously, on the human side, it's more about modeling, less about real life testing, because it's hard to find people who are interested in doing that, frankly. Turning towards the operations domain, two master projects, flight autonomy and integrated aerial services. And so flight autonomy looks at researching and developing technologies around application of increased automation within aircraft, from a crew reduction perspective, workload relief, to remote operations, and to fully autonomous operations, if you will. We have significant efforts going on around synthetic world generation, the perception piece, the path planning, as well as human-machine teaming. The other master project, which focuses on some of the specific applications of AAM technology and capability, and really broken down into three areas. So in the middle on the bottom, remote sensing, which deals with the application of technology on using AAM as a platform or as a truck for things like Earth observation and inspection. We also have a very focused activity on robotics for contact-based tasks, leveraging a deep robotics capability that we have at the NRC. And that includes things like doing contact-based inspections and repairs, that sort of technology application. And then finally, at the bottom on the left, we have a focused area around technology development for counter-drone technologies, primarily security and defense, and for other government departments within Canada, as well as this is where we focus our UTM, or traffic management research, that's obviously done in collaboration with Transport Canada, our national regulator, as well as NAV Canada, who's our national air service provider. Of course, we recognize that the technologies need to develop along, in lockstep with regulation. And so, as we've developed our research program, we've had a strong alignment ongoing with Transport Canada's research needs. And so, the image here is a bit of a depiction of how this alignment works. You can sort of see on the left some of NRC's focused areas within the technology building blocks that I just touched on, and then on the right is Transport Canada's RPAS task force R&D program requirements. And so, good alignment there. And just for an example, taking sort of number 7 on the list. Flight autonomy. We're doing flight autonomy research within our organization, and we formed a certification of autonomous flight systems working group with Transport Canada, as well as actually with the military regulator within the Royal Canadian Air Force to study and help transfer lessons learned and knowledge from our research into the formulation of standards and regulations. Excuse me. So beyond integrated area mobility program, I mean, there's a number of other development activities going on with Canada, within Canada, and of course, just a small sliver of time isn't enough to sort of touch on everything. But one specific item I did want to touch on additionally, or highlight additionally, is the Canadian Advanced Air Mobility Consortium. And so it's a federal not-for-profit structure that has regional executive committees to drive a national strategy and innovation around AAM in Canada. And NRC is proud to be one of the founding members. And so it's within this national strategy context that CAM looks to have regional implementations through development of technology and demonstrations on a regional basis. So starting in Vancouver is our first national AAM city, and then building out from there into Ontario, Quebec, Atlantic Canada, and into the north. Ultimately, we want to create and catalyze a sustainable, equitable, and profitable AAM sector, and really focusing on the big 3: economic impact, environmental impact, and societal impact. As well, within this sort of the CAM context, we also are quite proud of the 6 pillars that we have established here: equity, inclusiveness, resilience, emissions, accessibility, and intermodality, to help make AAM an agent for global positive change overall. So currently CAM has 35 members from all over the globe: Canada, States, South Korea, Japan, United Kingdom, and it continues to expand. And starting this summer, we'll be executing some demonstrations in the Vancouver area, focusing first on health applications, but then that will evolve into rural and urban operations, and then we'll see that model transition to other parts of Canada. And so with that, that's a very sort of quick and dirty overview walkthrough. I mean, there's so many activities going on within Canada. I mean, it's just sort of the tip of the iceberg, so to speak, with a bit of a Canadian analogy and the cold weather there. But I hope it provides a bit of a flavor of the work we're doing, and hopefully maybe sets the stage as I listen in, and an opportunity to connect and discuss ways we can collaborate and align with other national partners. And so, in closing, again, I wanted to thank everyone from NASA for your leadership in setting up this session, and for the opportunity to talk just a little bit about what's going on in Canada. Many thanks, and back over to you, Justin.
Duff, thank you so much. Really appreciate that survey, that perspective, and frankly, the weather report up in Canada as we look towards spring here in the United States.
Exactly.
Very much appreciated. So we'll shift our focus here a little bit to Asia, and invite the next speaker. Youngmin Chun is a principal researcher on the Smart Air Mobility team at the Korea Aerospace Research Institute, KARI. So invite Youngmin to give us some perspective from KARI.
Thanks, Justin. I appreciate for your introduction. Hi, everyone. It's quite early here in Korea. It's 3 a.m., but good morning, good afternoon, good evening. And I'm very glad to have a chance to to introduce what you're doing in Korea for UAM, which you call KUAM. Before I start, let me give you a brief introduction to CARI. CARI is a government-funded organization to lead civil aerospace R&D in Korea. And CARI is leading an eVTOL development project, which is called OPPAV, optionally Pilot PAV. And this project was launched in 2019, and they're preparing for CDR. It's a one-man seated vector thrust eVTOL. The pictures at the bottom show the 30% subscale flight test, which was carried out at the end of last year. Okay, today I'd like to talk about KUAM roadmap, UAM Team Korea, KUAM Grand Challenge, and R&D projects to support GC in Korea. KUAM roadmap is a government leading roadmap to envision UAM in Korea by phased concept. There are 6 key strategies in a KUAM roadmap. Number 1, to support safe UAM operation, we will revise and prepare regulatory frameworks for UAM, and as part of it, we will conduct KUAM Grand Challenge. Number 2, to create robust UAM ecosystem in Korea, regulation-free spatial zones will be designated for UAM operation and demonstration. Number 3 is a step-by-step strategy to increase public perception. So we are planning to start cargo delivery service first prior to passenger on board. And number 5 is supporting sustainable and healthy industrial ecosystem by preparing rules for UAM operators, referring to those of ground transportation, so we can avoid asking too much at its initial phase. What's UAM Team Korea? UAM Team Korea, we call them UTK, is a public-private cooperation body organized based on the roadmap. There are 8 major tasks of the team. And the first and the most important one is UTK will lead to discover and develop new UAM policies and R&D projects in Korea. And as a part of it, the UTK members are developing a KUAM technical roadmap these days. UTK was first formed in June last year, and more than 30 entities in Korea were involved, as you can see in this slide. The team is led by MOLIT, Ministry of Land, Infrastructure and Transport, and CARI and KIAST are supporting from technical and certificate perspective. KUAM Grand Challenge. I can say this is one of the most important topics now in Korea. The goals is to evaluate the safety of UAM under a Korean environment before launching initial commercial service aimed at 2025. GC is supposed to provide technical basis for the KUAM flight rules, which will be established in 23. It will encourage collaborative UAM R&D programs and ecosystem building through public-private partnerships. And whoever wants to provide UAM commercial services in Korea will be asked to show safety compliance in Korean environment. And we believe GC will be a good chance. The detailed information about GC, such as how to participate, what are required and benefits, will be announced in the mid of this year by MOLIT. This is the preliminary GC schedule. There will be 3 steps in GC. The first one is preparation step to build and install buildings and facilities to support GC at a flight test center. And GC1 will begin sometime in 22 until the end of 23 at a test center. conducting UAM key features validation tests. And GC2 will begin sometime in 23 until the end of 24 at airports and urban areas. GC is a large-scale phased approach demonstration program open to not only Korean, but also international industries and R&D organizations. And in GC, we divided KUAM into 5 categories, as you can see here. In case of aircraft, we'll rather focus on its operational aspects and environment impact than the aircraft itself. For the airspace, we'll focus on reliable integration with ATC and safe management. The operation, we'll study on rules of operations and licenses. And for the infrastructure, vertiport will be the main target, including design, construction, operation, and charging facilities and security check will be also included. In case of community, noise ground impact and urban micro weather will be handled. As a part of GC0 phase, test infrastructure and facilities are in design phase, and you can see their draft specification. And we'll prepare a mobile noise lab to measure noise at urban areas as well as remote open areas. Mobile CNS facilities, which can cover a medium-sized area, which is about 20-kilometer diameter, will be developed. Mobile monitoring facility will integrate and monitor all the data from the GC infrastructure and aircraft. This is the concept of KUMGC CNSI. The items with numbers will be prepared as part of GC infrastructure program. An R&D project. GC interacts with 3 other projects. Project number 1 is a kind of design project, which designed other 3 projects and allocate them. The number 2 is GC itself. And then number 3 and 4 are R&D projects, and I will talk about them in the next slides. IUM OVX will develop a cyber physical system to validate GC operational safety and to verify the KUAM flight rules. It interconnects physical components such as weather, traffic, aircraft, and so on, with software or cyber components such as PSU and vertiport under KUAM environment. This project will enable us to verify operational procedures, communications among stakeholders, and licensing requirements. KUM CNSIs will establish a CNSI infrastructure and operation system at initial commercial service routes. It will secure and share CNSI data based on commercial mobile network among stakeholders. By demonstrating KUM CNSI and ATC integration in GC, we will be able to forecast how to build KUATM after 2030. As a summary, in Korea, we have been prepared KUM roadmap, UM Team Korea, KUM Grand Challenge, and other R&D projects, and more are being prepared. International participations are welcome to any KUM activities, but especially on GC. We figure out that the more we prepare, the much more needed. So we'd like to suggest gather global efforts on UAM, like today. NASA's AAM International Day is a great chance to begin international collaborative work for AAM and UAM. Let's make a regular and formal channel where we can share and discuss our UAM activities and efforts. Thank you.
Youngmin, thank you so much for sharing the KUAM project. Really appreciate that perspective and information. Thank you.
Thank you.
So we'll shift now 9 time zones, I believe, to the UK. And the next presenter is Gary Cutts. Gary is the Industrial Strategy Challenge Fund Director for Future Flight at the UK Research and Innovation, UKRI. So Gary, we look forward to your presentation.
Excellent. Hopefully you can hear me satisfactorily.
Oh, Gary, we're having trouble hearing you.
Clearer.
That's a little better. Can you try again? I think it was the headphones.
Yeah, I perennially have a problem. If I put the headphones on, they don't work. If I leave them off, I need them. Let me try without headphones, and please do shout if this is not clear. So again, thank you, like the previous speakers have said, thank you for the opportunity of joining you across the world, and to NASA for establishing this event today. 10 minutes, as has been noted, is quite a quick time to try and talk about a very extensive set of projects. So I can give only a flavour in the time available today. So firstly, let me set the scene. UK Research and Innovation is a UK government body that brings together all of the university academic research bodies across the UK. Innovate UK that drives innovation, government-funded innovation in industry and beyond. The Industrial Strategy Challenge Fund, which I won't describe in great detail, is a slightly different construct. It is where we've, in addressing significant government priorities and challenges, a set of programs were created over the last 3 years where we think there are things that matter, so societally important challenges to be met, but where there's a relatively near-term opportunity to make a substantive difference. So they're a different construct, and they work across academic research into industry and very much looking at application of significant challenges. So that's the construct that we have. The Future Flight Challenge, is very much looking at the aviation system that comes from new classes of air vehicle. It is absolutely paralleled with the other equivalent international bodies we've been talking to today. So the way we see the industry, and you'll probably cunningly spot this is really several slides put into one slide to try and allow me to talk quickly through it. But the way we've seen this is that initially this is obviously tech-led. The technology has come together. It is converging in a way that allows the creation of a range of new, novel and sustainable air vehicles. Our scope of supply is drones, so freight carrying or service providing, but non-passenger carrying vehicles. And here we're talking, multiple tons of class, not just the lightweight 10-kilogram drones. Advanced air mobility vehicles that we know all about, but we're also taking in more classic air vehicles where there are sustainability developments, either electrically or hydrogen powered, or where there's an application of other technologies such as autonomy. So we are looking at all of those classes of novel sustainable air vehicles. So the Future Flight Challenge is pretty broad in that, but it is not looking at the vehicles directly at all. Our view is that they are well funded and capitalised, lots of research programs underway. Our strong view when the challenge was launched is that the aviation system, the integrated aviation system, requires really far-reaching changes in order to allow those vehicles to come into being, very like the NASA programme. So we've laid out a government-funded challenge. It is a £300 million UK government programme to develop those aviation systems. And the little diagram at the bottom left just gives you the scope of this. And again, the time doesn't allow us to dig into all of it, but we are looking at some of the air vehicle technologies, but not the air vehicles themselves. So that includes the communication, detect and avoid technologies, and some of the capabilities around autonomy, because rather like the NASA presentation, we see autonomy as eventually, if not initially, being a key enabler for these vehicles to become substantive in use. Second, there's a whole set of activity around control and regulation, probably quite badly titled, but that is the traffic management systems, the regulation environment, but particularly the air traffic management systems, which today could not begin to cope with these new classes of air vehicles. We also see there are challenges in two aspects of the infrastructure. The physical infrastructure, everything from what is the concept of a vertiport in a city, how do these vehicles land and interface in classic airports, but right through to the power supply systems. How do you charge vehicles, be they electric or hydrogen? But the second class of things in the infrastructure is the digital infrastructure. It is quite clear that you need a very robust, cyber-secure, integrated, standards-driven digital system in order to allow these vehicles to fly. So that's a substantive challenge as well. And the last class for us were what we call new operating models, which is a catch-all for kind of everything else. But this is a really important box for us. It's broadly a set of social science considerations. So where is the public on this? How do we demonstrate public utility? How do you have people understand and engage with some of the perceived concerns around safety, intrusion, noise, and where does the public get its view of these as a vehicle for good? Right through to the economics and service concepts. So Future Flight is funding activity in all those areas, but the key thing for us is we are an integrating challenge. We see this as the most complicated system of systems, certainly that I've worked in, where we cannot decompose the requirements to each of those pillars. We have to work with them in concert. So as you're developing the aircraft, you have to develop your concept of air traffic management, the concept of regulation and the infrastructure all in concert. And we see there have been some substantive things that have to be done across that, such as the environmental considerations and developing the overall aviation safety case. So that's the challenge as we see it. I won't dwell on this slide for time, but we've taken a phased approach, and we had to take that phased approach because this is an emergent system. It's not deterministic, and I think everyone on this call understands that. We do not understand how this system will end up. We know we're developing new markets and a multitude of new markets using a whole basket of new technologies across the aviation system. So we took three phases of approach. The first, which was really through the start of 2020, was to bring together the industry. I think that's been quite an important activity for us, bringing the wider aviation system together and having all of those players, from software companies to local authorities to aviation regulators through to airports and cities, as well as the vehicle manufacturers, understand each other's concerns. We're now in the development phase where we've got a whole range of funding programs, which I'll describe on the next slide, which will deliver over the next 18 months. And roughly that stage of the program was driven by us announcing 6 problem statements, significant problems that we felt had to be overcome to realise our vision of the new aviation system. So we've invited bids from industry, academia and public bodies to address specific challenges. On the final phase, which runs through to March 2024, what we're aiming to do is do a full system demonstration of all 3 of those classes of vehicles, where we'll fly them in real life use cases in live airspace, ideally in the same airspace, and exercise every aspect of a new aviation system. So we're looking for the industry to come together and demonstrate a new air traffic management system, new vehicles, use cases, the software system and the physical infrastructure. So it's all about full system demonstration. Just 90 seconds on what could be a 3-hour presentation. Where are we and what's going on for us today? As I said, we've launched a number of projects. We are right now funding 48 projects with 196 unique organisations in the UK. So suffice to say, there's a real good news story in here in an aviation system that's largely in crisis. This is a massively vibrant ecosystem, a message we give to government all the time. This is full of lots of interesting new entrant companies partnering with established companies. So the projects that we're running cover everything. Time doesn't allow me to go through them, but everything from operations and logistics concepts, people developing the concept of infrastructure and vertiport, a whole range of activity around integrated airspace and air traffic management systems. But what we do have is a real focus on use case, people working with local communities and local authorities to look at how you will bring these vehicles into operation and demonstrate them. I've alluded to this, but we've created a whole range of new partnerships. The little figure at the top right, what it's really showing is the bulk of the activity we have is with small and medium enterprises and or new entrants to the industry. So those partnerships of new thinking with established aviation companies, that's driving some real new thinking. We've done quite a bit of work on the socioeconomics, and there's more to come. So can we look at what's the market dynamics? What's the essential case for having vehicles like this? And that's a really important piece of thinking to engage with the public, that we can describe the reason for the technology. Two final things I want to cover before I just leave you with some example projects. We've been doing a substantive piece of work around the safety case. We will not drive the safety case, industry will drive that collectively, but we had a strong view that we can't just leave industry to do that alone. So I funded directly a piece of research on the safety case for these new forms of flight. That's about to be published, and what we've done is take a look across the essential safety case we have for the current aviation system. What are all the facets that give us the enviable safety record we have? And of course, we all know that's not just the regulation, it's much more about the culture and the way that industry behaves. So how do we achieve our current safety numbers? And what we've done is identify all those aspects that will be challenged by our vision of the new aviation system, and start to lay out the areas in which we'll need to develop new control mechanisms in order to achieve a safety record. And finally, we've got a whole range of work going on a very detailed roadmap that takes us out to 2030 and beyond, which we'll lay out very soon as well. So there's a wide range of activity ongoing. And what I wanted to leave you with, because time is very short, is just some example projects here. So they're in the pack when it comes to you. But as I said before, we have a large number of projects that we're funding, 48, with many organisations. We're spending in the next 18 months £33 million of government money. So that's more like 60 million of total money. And for us, that covers the entire aviation ecosystem. We have players from every walk of life in aviation working together. And the real message for me is that bringing in new thinking alongside the existing aviation system, that partnership that's being created, that feels incredibly powerful in driving us to this new aviation system we're trying to get to. So with that, I'll thank you again. I'll hand you back.
Gary, thank you so much. Indeed, it's a real challenge to summarize all the great work in the Future Flight Challenge in just a few minutes, but that was an excellent survey of the work that you're doing. Thank you. We'll shift our view now to Germany, and it's a pleasure to introduce Christian Ischmann. Christian is the challenge coordinator for Unmanned Aircraft Systems, UAS, at the German Aerospace Center, DLR. So Christian, we look forward to your presentation.
Thank you, Justin. Also from my side, pleasure to attend and participate in your International AAM Day. Thanks for this. I'd like to use the 10 minutes just to give you a brief update on the German as well as the European research perspective on UAM. The reason is as follows. DLR is Germany's aerospace research organization, by far the largest in Europe, with probably €1 billion per year just for aeronautical and aerospace research, but at the same time highly connected to the European research. And that's why I really want to really put the focus on both and to show you how this is connected. From the strategic point of view, it's of course, as every country, also Germany has related to UAS and UAM an action plan that is really focused on how these applications can be used in the future. And since DLR is belongs to the Ministry of Economics, we have really the direct focus on the industry. So this is one motivation in Germany. And at the same time, in Europe, you might be aware of that we have the European Green Deal since end of 2019. And this new strategic document really puts a lot of focus now on the climate change, on sustainability, and especially the aspect of circular economy also have a huge impact now on UAM too. So these two already at the strategic framework from this. And the third part is what we had also before. That's the European Flight Path 2050. So really our strategic forecast and guideline for the next decades for whole European research. And there it's really customer-centric mobility that is in the focus. And UAM, it's really perfect fit for this, especially when we have a look at one of these goals where 90% of travelers within Europe should be able to complete the journey from door to door. So where they start from to where they end within 4 hours. And there, of course, with a look at all the transportation modes, UAM could be really good means to support this goal. So this from really the national and the European strategy perspective. And when we just have a look at the German research side, so really DLR itself, of course, what you can see here in blue, this is really our basic aeronautical research that we already, let's say, what we've been doing since decades. But especially for UAM, you can see the new part. So in orange, everything that is airspace management, but also especially the red ones that are dealing with environment, social acceptance. And this reflects also who's participating on DLR side on topics such as UAM. So of course we have the classical institutes on flight systems, flight guidance, but more also, for example, the Institute of Aerospace Medicine, having a look at psychological and physical effects on the new urban mobility, but also institutes from space and from energy and transport areas, which are dealing with new propulsion systems or cyber secure communication lines. So here really highly affected this topic, or really a strategic topic at DLR itself. And the next slide, just a bit to give you an overview of where's the main focus at the moment when it comes to the research topics. I mean, it will be quite similar to what we see in other countries, but just to highlight it, first of all, autonomy is really what is bothering DLR at the moment when it comes to UAM. So of course, when it comes to flight guidance approaches, also using or having at least a look at AI, what is possible there in the future, not only with a look at the vehicle, but really also with regards to UAM, with a look at the system, and then any kind of options that we have here with regard to the pilot, but also it can be passenger transportation, cargo transportation, and then any scale. What you can see here from really 1 ton small cargo transportation, which is autonomous and low altitude delivery, up to really an autonomous A340, for example. So autonomy is one part. The second part that we have is, of course, urban airspace integration in Europe, really under the framework of U-Space. And this is something that is, for us, really the basis for also connected to autonomy that we need and when it comes to regulations and how to structure the whole thing. And that is where everyone at the moment, not only in Germany, but also in Europe, is looking at EASA when it comes to regulations. I mean, we will see Maria later in the panel discussion on this topic, and I think we will hear brilliant news from there. But at the moment, you can see that, especially in Europe, everything is focused on this when it comes to the types of operations, what will be possible in the future here. So this is another area. And a last example, DLR has Europe's largest fleet of research aircrafts. And of course, we are quite keen on having demonstrators. So just 2 examples of what is a bit the preparation for urban air mobility. It doesn't look like urban air mobility, but the systems that we are testing there are. So on one hand, on the lower left, it's fuel cell test demonstrators, where we have a look at the urban air mobility vehicle size, where we can see whether fuel cells are what is needed there in the future. And let's say the upper size of CS23 up to 19 seaters in terms of hybrid electric propulsion, what is possible there. And at the end to really to fuse or to merge it into the UAM systems that we're aiming for. And when we talk about demonstrators, DLR was granted and really happily granted 2018 by the national government, the National US Test Center. So in 2019, we bought a small but still active and operational commercial airport, which is now transferred to our US Test Center, which is for us the main hub for all the UAM activities in Germany, and where we can test any kind of virtual but also physical applications and everything that is needed. And for us, we see that really the demonstration phase is key in this whole thing. So this is a really, really brief overview of the national activities. And now coming to the European research, DLR is part of the AREA Association, so the Association of European Research Establishments in Aeronautics, currently represented in 14 European countries, so with other DLR counterparts. And DLR is quite happy to lead under the AREA umbrella, its so-called Future Sky Initiative. They're the urban air mobility theme. So there the European research is a bit coordinated. So of course you have your national activities at DLR, at NLR, INTA, and whoever, but we use this method in this association to really coordinate this on the European level. So of course we have a UAM roadmap where we try to see where we want to go together, of course also alone, but let's say a bit harmonized within the next decades. We have several action lines from the basic strategies over the aspects of environment, feasibility studies, up to really the demonstration integration phases with several sub-action lines. And this roadmap we mainly have in order to really provide ideas also for projects, bilateral projects, but mainly European projects. And just as examples, I just said that we have the National Test Center, and one basis for...
Io non sto vedendo il coso international.
Sorry.
Sorry about that, Christian. We just...
No worries. So here one project was the Ringo project. So on the European level, we have been investigated what kind of research infrastructures for UAS and UAM would be needed in the future. Where are the gaps? Where are the overlaps? Really, in order to see how we can consolidate the work internationally, and here with the focus on Europe. So at the end, we could see that this has an effect in Germany. So here, Kochstedt, our DLR airport, is at the moment the hub in Germany to coordinate the work that is being done there. On the European scale, we have the other organizations who has their test centers, which is also then a European map where we try to harmonize the activities and to distribute a bit the workload and the kind of tests there. And there, I mean, as one of the purposes of today's presentations, to see where is a bit an approach for international collaboration. There it definitely is. I mean, we have quite close collaborations with NASA, with JAXA, but here, just as an example, is one option where it's really, really a good opportunity to see where, when it comes to demonstration projects, to step in. And perhaps as another example, we have in the EU since 2018 the urban air mobility initiatives. So it's really a conceptual demonstration of what can it be in the future. It's not only passenger transportation, but really the whole thing of applications for, at the moment focused on really medical transportation and really systems for the government. But this is really something where 12 projects have started, even 2 that is cross-border. So really also having a look at the regulations that are needed. It's 17 cities participating. So the whole thing is a bit similar to what we see at the NASA AAM national campaign. So also here, there's really the focus on when we have the research being done, what is needed then in order to implement it and in order to see the applications in the future, combined with the regulations, together with the industry, together with the communities and the states, really to make it running. So this just in these 10 minutes as a brief outline what we are going to do in Germany and in Europe. So thank you very much for this opportunity and this quick overview.
Christian, thank you so much for that overview of the UAS work in Germany and as well as the work there in Europe. We very much appreciate that.
You're welcome.
So we will we'll cross a few more time zones to India, and very much looking forward to the next presentation. Bindeshwari Rai is the Senior Manager for Programs and Partnerships at the India Smart Grid Forum, as well as the head of the Technical Secretariat for the Global Smart Energy Federation here in the United States. So Bindeshwari, we look forward to your presentation.
You're on mute, by the way.
Yes, hello, Bindeshwari. Can we help with anything? We're happy to pull up your slide deck now if that would be of assistance.
Can you hear me now?
Yes, we can hear you now. That's perfect.
Great. So a very warm greetings from India to all the participants. I'm Bindeshwari Rai from India Smart Grid Forum, which is a think tank promoted by Ministry of Power, Government of India. For the last 5 years, we have been working on smart mobility solutions for smart cities. We are thankful to NASA for inviting us to present at this August occasion. I'll just share my presentation. So as you might be aware, India has also started its journey on digital sky and looking for various smart mobility options to promote clean environment, safe mode of transport, and futuristic solutions. Indian cities are struggling with major issues which need immediate attention. These problems have aggravated and a big concern for government. The issues are traffic congestion. Our recent data shows that around $22 billion was lost last year due to traffic congestion in New Delhi, Mumbai, Kolkata, and Bengaluru only. Urban air pollution is another major concern. Unfortunately, 16 of the 20 most polluted cities are from India. Road accidents in 2020 only, India recorded over 238,000 road accidents. COVID-19 has drastically changed the lifestyle around the globe. In India, the purchase from e-commerce portal has increased exponentially. This has created a huge demand for home and office delivery of goods, which is again a big concern for the traffic. India is looking at UAM as a possible solution for the city issues for safe, smart, and efficient transport. So India the government is already starting so many programs which may be enablers for creation of an ecosystem for UAM in India. Invest India program facilitates global industry to get benefit of the economical resources available in India, and they can establish the manufacturing units in India for drone and air taxis. The government's Skill India program established Skill Ministry and is running various skilling programs to meet the requirement of industry. The grid modernization program is empowering the utilities, and the utilities are now ready to support integration of UAM e-mobility in the ecosystem. The Smart Cities, which is very ambitious program of Government India, is helping in building smart infrastructure. 2/3 of the buildings that will be in 2035 are yet to be built, can be built with UAM friendly facility. So Ministry of Civil Aviation has already prepared the drone ecosystem policy roadmap in 2019 with a focus to foster innovation in the US market by enabling commercial use of UAS, including autonomous UAS, and expanding its operations beyond visual line of sight. The roadmap also aims to realize the tremendous potential of the Indian US market in the form of economic growth, public and societal welfare, and job creation, and also to position India as a global leader in this space. The mission of Government of India is to ensure high and uniform level of safety for US operations, to foster innovation, entrepreneurship, and competition, and build infrastructure capabilities for UAM systems, to attract technology advancements and investments, both domestic and foreign, to provide alternative solutions to critical and high-risk problems. The recommendations in the roadmap include BVLOS operations, autonomous operations, drone corridor, airworthiness, US traffic management, digital sky service providers, recommendations on pilot training, drone ports, payload cargoes, Make in India program, and insurance. With this, I would like to invite Mr. Reji Kumar Pillai, President India Smart Grid Forum and Chairman Global Smart Energy Federation, to talk about the UAM potential in India. Over to you, Mr. Pillai.
Good morning, good afternoon, good evening to participants from around the world. Namaste. Next slide, Bideshri. Yeah, as my colleague has mentioned, we are a think tank promoted by Government of India, particularly Ministry of Power, advising governments, utilities, and regulators on electric grid modernization. And we are not in the airspace area, but people might wonder, why are we here, not anyone who is directly from the Ministry of Civil Aviation or somewhere. The reason is that all these new vehicles, flying vehicles, electric vehicles, these are all going to be connected to my grid at some point in time. And anything which is getting connected to the grid is a cause of worry or a concern for us. So we have to support that such a way that grid and new devices which are connected both are integrated. So that is why we are here. And a couple of months ago, we have been in touch with NARI, and we wanted to undertake some feasibility study. There are some very compelling business cases in India for passenger drones. I will come to those slides. So why this is today relevant is because India is also on fast track to adopt 5G network, which will support drone operations, advanced analytics and robotics, digitalization, all these areas we are in the forefront. Also battery technologies, the high efficiency batteries which are required for drones. Next slide, please. So in 2020, actually in 2019, Government of India issued some roadmap, and 2020 they issued a draft regulations for unmanned air systems. So the first one, the roadmap which is issued, which has made possible remote aerial surveillance, monitoring, law enforcement, geographical mapping, etc. Next slide, please. Yeah, this rules is issued, which is still in the draft form. We say it's too draconian, and we have been advocating that it has to be more open. For everything, we have to go to Director General Civil Aviation. They will authorize people to import or manufacture, and also sell the drones to people who are again approved by DGCA. And again, only nano class drones which will be allowed to operate in general only by a qualified remote pilot will be permitted. So everything is controlled. So this will finally, when it comes out, it will be much more diluted than the draft form. The insurance part is also, it talks about it, but needs more fine tuning. Next slide. They talk about the payload, what payload it can carry, what it cannot carry, regarding the ownership, operation, everything. There is some, this is available in the public domain, and I encourage everybody to comment on that. And we have been advising them to make it more drone friendly, or the business cases for us. We will come to that now. Next slide, Bindeshri. Yeah, so they, as I said, they have already permitted the beyond visual line of sight drones, but its use is very limited to military operations and some of the monitoring systems. Last year, post-COVID, law enforcement agencies been using drones in most part of the country. That has really given a big push to these things, and that is how this draft regulations also came up. We really don't know how soon e-commerce deliveries will be commercialized and operationalized in the country, but passenger drone is going to be much more relevant for our cities. Next slide. So ISGF wish to undertake feasibility studies for introducing particularly passenger drones in cities like Bangalore, Mumbai, Delhi, etc. And we are open for looking for partners who can collaborate with us to undertake this feasibility studies. And government in general, state government, and other stakeholders are in agreement with this. Why is because I talk about these three cities. What are the places where we wanted to do this study? Next slide. You take the case of Bangalore. From Delhi to Bangalore, I can take a flight and reach there in less than 3 hours, 2 hours, 40 minutes. From Delhi to Bangalore, I reach. But from Bangalore, if I want to reach the electronic city where all these IT companies are there by road, it takes as much time. Any point during the day, it takes well over 2.5 hours to reach. A drone could take you less than 10 or 15 minutes. Same is the case with the government headquarters, state government headquarters, which is Vidhan Sauda, all these places. So if I, previous slide, stay back in the previous slide. So if I pay $100 for going from Delhi to Bangalore, and another 2.5 hours I have to struggle on the road, I don't mind paying another $100 on a drone going from the Bangalore airport to electronic city. There are thousands and thousands of people who can afford to pay that, and there is a compelling business case for that. And same is the case with Delhi and Bombay. Next slide, please. Yeah, this is Mumbai. Again, Delhi to Bombay, I can reach less than 2 hours by flight. Bombay airport, if I have to go to the city center, which is the South Bombay, it takes more than 2 hours any time during the day, and at worst times it can take as much as 3 hours. Same is the New Bombay or the Navi Mumbai, which we call, which is on the other side of the sea. That also from Bombay airport, it can take 2 to 3 hours. The distance is only some 20-23 kilometers. So there are a large number of people who don't mind paying, whether it is $50, $100, or even $200 to cover those places in reasonable time. And Delhi also are some satellite cities. Next slide. And that, the previous one, the Delhi one. So a couple of routes. The Gurgaon is the place where all the IT companies and MNCs are there in Gurgaon, which is outside of Delhi. And from there, it's only 16 kilometers to the city center, which is Connaught Place. It can take as much as 2 hours on an average day pre-COVID. Even now, things have opened up and it takes such long time to reach there. So all these are unique and compelling business cases where we could introduce, but we would like to start with Bangalore or Bombay, because in the case of Delhi, there are different states involved, the Delhi state, central government, and the Haryana government. So there are more logistical problem for us to do. But introducing a UAM service in Bangalore or in Bombay is much faster. And as we said, there are no specific regulations, and this draft regulations, if we work around with the right stakeholders with the right input, we can have a very, very UAM friendly regulations in India much faster than in Europe or in North America. And we can introduce the services for which we look forward to collaborate and co with technology providers and other experts to undertake this feasibility study, which there are many agencies to fund. We look forward to receive expression of interest. Interestingly, India Smart Grid Forum, we do an annual event. It's a very big event which we do. It's going on. We started it yesterday. It will end on Friday. And we have kept a roundtable on UAM, which is tomorrow. It's India time, 11:30 a.m. onwards. We have a 2-hour session in which many experts from NASA, Germany, and other regions will be participating in that. This is going to be the very first UAM discussions in the country with foreign participation, and we look forward to working with the international community in introducing UAM services in India. Thank you very much. Namaste.
Everybody, and AG, thank you so much for that overview of the excellent work that you're doing there in the India Smart Grid Forum. We really appreciate that, and note that you provided that presentation in the middle of the night. Thank you so much. So we will switch to a far southern latitude next. And it's my pleasure to introduce James Wong. James is a businessman and a professor of aircraft design and director of the eVTOL Research and Innovation Center at Nanyang Technological University, NTU, in Singapore. So James, we welcome your presentation.
Hello. Thank you very much for the introduction. Okay, right now I'm currently residing and living in Singapore now. So many of you may remember 10 years ago I designed the world first eVTOL aircraft, the Augusta Westland Project Zero. So right now I'm in Singapore. I'm trying to recreate and design the next generation one. So here's our Singapore vision for AAM. Singapore has built its reputation as a smart nation over the years. Singapore topped the Global Smart City Performance Index across 4 different areas: mobility, health, safety, and productivity. There's an ongoing digital revolution, and we know that advancements in digital technology are transforming the way we live, the way we work and play. However, as Singapore was a very small land area, no hinterland, no natural resource, Singapore's survival hinges on our ability to innovate. That is why we recognize AAM use is very beneficial to Singapore as a smart nation vision. So this is Singapore. It's 721 square miles, 50 kilometers, and total population 5.8 million people. And we can average about we have averaged 7,800 people per square mile. That's pretty dense. If we take a look back here again, we can take the 5 circles represent the 5 airports on Singapore Island. 2 of them are civil and 3 are military. So it's extremely challenging for the regulations and also the user alike to navigate in this area. So that's one of the challenges. We have both safety, security, and the noise. It is very important that while we push the boundaries for AAM it needs to be done in a very safe and responsible manner. So let's take a look what we consider as the 5 building blocks toward establishing AAM in Singapore. So there'll be regulations, infrastructure, public acceptance, technology, and partnership. Let's take a look at the first one, the regulation. Let's start from the left and move to the right. So in terms of balanced and sustained approach, in our policy and implementation deliberation, we need to achieve the right balance between enabling the beneficial use of drones and also manned eVTOL against maintaining high level safety, security, and privacy. Now let's take a look at the middle block, the whole of the government approach. It is very important. Enabling AAM into our airspace is more than just a civil aviation authority problem. We are taking the whole of government approach to policy development and implementation. It's important to work with other ministry and government agency. Finally, let's move to the right to progressive and adaptive regulations. 12% of our land in Singapore is being set aside for roads and transportation infrastructure. With a growing population and more than 1 million cars in Singapore, this is why we're exploring AAM as a third dimensional alternative. The government must work closely with industry and research institute to ensure the regulations are kept abreast with the technology advancement. Now let's go to number 2, the infrastructure. As many of you may have heard already, that by 2023 in Singapore, we would like to start operating urban air mobility, have the first eVTOL flying. Right now, we're collaborating with Skyport to building up a vertiport in Singapore, which we would like to have it ready for sizing purpose by 2023. And the vertiport will include all kind of infrastructure like scheduled maintenance, gates with navigation aids. Even though it's a very small vertiport, but it also need to have closer working relations with air traffic control, maintenance, safety, charging station, passenger facility. The next building block is we need to investigate what is the public acceptance toward AAM. So this is one study that NTU has done. They did a survey of 1,050 Singapore local residents to see what is their acceptance toward in the commercial industrial use of unmanned air system and manned system. As you can see, for majority of the purposes, maintenance, inspection, communication, they average all above 70%, some as high as 90%. Except one of them, the third one, transport people, that one's 62%. So that indicate people are still want to wait and see how does the drone will work first, and then eventually to decide whether they want to have the manned eVTOL. So they accept, but even though it's 62%, that's still relatively high for a country to accept air taxi operation and urban air mobility. Now let's take a look at number 4, which is technology. Currently, in 2019, so Singapore has launched its first eVTOL Research and Innovation Center. And I believe this is one of the first eVTOL research center in the world in the university level. So our goal at the NTU is, let me describe our mission statement, to be the world's leading research and innovation center for both manned and unmanned eVTOL aircraft. We nurture talent, create and incubate innovative, commercializable eVTOL technology. The key word here is commercializable. So we're not just here to do academic research to produce paper and push the frontier of technology, but we also like to produce results that can be commercialized and help transform the whole future of transportation. So that's our mission statement. And these are some of the key areas that we are currently working on, including aerospace engineering, which covers all the core technology required for eVTOL research, and also system engineering and the management, clean energy solution. We have a department that specializes in doing electrification, fuel cell study, battery, and energy. We also look into manufacturing. How can we reduce the manufacturing cost and the throughput of manufacturing eVTOL aircraft? Robotic, intelligent, autonomous system, micro and nano fabrications, and others even including air traffic control. We have a $100 million research facility that we work very close with our Singapore CAAS to examine how does air traffic control can be improved. Partnership. We welcome partnership from around the world and locally. So even though we're an academic in the university environment, we're very good at developing the low TRL levels, like usually 1, 2, and 3. These are our core competency. By establishing our eVTOL Research Center 2 years ago, my goal is to lead the center and collaborate with both local SME, large company, and international companies, and to raise it to the TRL level at least 6 by building a flying technology demonstrator. And then beyond that, we'll continue to collaborate and support a commercialization actually into a successful eVTOL aircraft that will satisfy this 3.175 ton, that's right, 3,175 kilogram category of the eVTOL aircraft. And then this will help introduce a whole new AAM economy and efficient transportation system, not just for Singapore, but also for our neighbors too. And these are some of the key research that we're currently focused on. We divide it into 3 levels. So 1 is vehicle design, 2nd is electrification, and number 3 is structure and manufacturing. So currently we have already working with many international companies from North America and also from Asia and also from Europe. Thank you very much. If anyone would like to partner or collaborate, feel free to send me an email, and my email address is shown right here. Thank you very much.
James, thank you. Very much appreciate that survey of the work that you've done at your university and there in Singapore. It was an excellent presentation.
Okay.
So we will switch now, again, several time zones to France. And our next speaker is Catherine Ronflet-Nadeau, the Drone Program Manager at the Technical Innovation Center of the French Air Navigation Service Provider, DSNA. Catherine, we invite your presentation next.
Okay, thank you very much for the introduction. Thank you for inviting me to this day. Can you see my slide?
We can, they look great.
Thanks a lot. Okay, I'm really very pleased to participate to this day. So I'm working at the DSNA Technical and Innovation Center. So I'm working for the French ANSP. And my presentation is really going to be focused on the integration of drones, and especially for the urban air mobility in the airspace. So at the Technical and Innovation Center, the objective is really to build a consistent vision, short, medium, and long term for US traffic management. Also to contribute to define regulation, tools, and standards at national, European, and international levels. Finally, we perform a lot of projects, exploratory research projects, but also research and development with industrial people, and a lot of experimentation. For example, very large-scale demonstration for CESAR, Single European Sky ATM research. So I want to spend just few minutes on what is happening right now. We are just changing from national to European regulation. In France, in fact, from a regulatory perspective, everything started in 2012. In fact, we were in a vicious circle because we had no regulation. So because no regulation, no drone flights, and because no drone flights, it was not possible to create a regulation. So what we decided to start with something very pragmatic, just to facilitate the development of drone operation. And for that, we contributed to exploratory research, to research and development projects, and to a lot of experimentation in order to gain some experience. And the result was that in 2015, we updated the French decrees in order, to put in the regulation what we learned in the project. From 2016 to now, we started to work with EASA on the harmonization, just to contribute to a European regulation. And since beginning of this January, we are applying now the EASA regulation. We are also contributing to the European New Space Framework. And right now, in fact, last week, there was an agreement on the new space regulation, and we are now contributing to acceptable means of compliance and guidance material, and we hope that they will be published at the end of 2021. And this is very important to foster, the new space activity. So as I said before, my presentation is really going to be focused on the accommodation, integration of drones in the airspace. Both of you know that in Europe, drones operation are risk-based. We have those three categories: open, specific, and certified categories of operation. But the access to the airspace is performance-based. So what we want to do is to be able to do an airspace risks assessment. And I put a S to risk because it's not only about safety, about ground risk, air risk, it's also about security, privacy, environmental issues. And depending on this risk assessment, we would like to create use space volumes and then to have the possibility to have a dynamic airspace reconfiguration when needed. Of course, everything will rely on information exchange. So we will build a common information services. And with that, this is the basis to create this use space. Then, of course, we will have to define operational procedure, to define the US requirement to access the different volumes. And the idea is that use space services will be able to mitigate some residual risks. And of course, the use space services could influence the US requirement depending on the way they are going to mitigate the risk. For us, urban air mobility is going to be, from an airspace perspective, of course, is going to be an instantiation of use space key principles. So you will find the same approach. We want to do this airspace risk assessment, ground risk, air risk, other risk, and then we will have to design these very low level use space volumes. We will define the concepts of operation. We will provide use space services adapted to urban air mobility. And of course, we will think of the abnormal and emergency procedure. And it's not, what I want to highlight is that we are not going to do that, not taking into account all the different steps. We will have to combine all these different points to have something consistent and to be sure that we will keep the sky as safe as it is today. Another point when it comes to urban air mobility is that it's a real challenge for the airworthiness of the US. So of course, in the specific category, we will do some operational risk assessment using SORA, the specific operational risk assessment provided by EASA. We will, of course, so this is for the drone flying in specific categories, so mainly for urban air delivery. But when it comes to taxi drones, passenger transportation, of course, we will have to follow ICAO Annex 8 and for sure the EASA future certified regulation. For now, we are using, and to do some experimentation, some demonstration, we are using some national permit to fly. I mean, this is just the beginning of the story. But within the context of CESAR, we started just this January 2021 a new project, which is very challenging because the idea is to have a demonstration in Paris region. So here you can see the map of Paris region. So you see Paris Charles de Gaulle, you can see Paris Orly and also Paris Le Bourget. So these international airports, but we also have a lot of small airports, and all these platforms, they are managed by Aéroports de Paris. So it was a very good opportunity for us to work with them and to try to develop some use space volume to manage these volumes with a dynamic reconfiguration in order to be able to accommodate some trajectories for small drones between the small airports. Of course, the first steps are not to fly to Charles de Gaulle or to Orly or to Le Bourget. So the idea within this project is really to create some trajectories and to be able to demonstrate that the use space dynamic reconfiguration will facilitate the development of such trajectories. Another point, and Aéroports de Paris is going to work on that, is to create in the Pontoise Airport, which is a small airport not so far from Charles de Gaulle, to create a vertiport and to demonstrate that it is possible to manage at the same time the vertiport and manned aviation on the same airport. Of course, it's going to be done step by step, but we have numerous stakeholders. Of course, we have the ANSP, the SNA. We also have the DSAC, which is the French regulator, Aéroports de Paris. I already told that. We have also some airports in Paris region. We have Hologard, which is one of the use space service providers in France, and they have something specific, which is a counter-US capabilities. They are using one holographic radar in order to detect non-cooperative drones. And this is very important when it comes to security. And then we have 4 drone operators. We have Pipistrel with a piloted electric aircraft. We have M3 system with a long-distance fixed-wing air pass. And we have Hihang and Volocopter with their highly automated eVTOLs. And in the future, they would like to carry passengers. The 2 first ones were supposed to be used more for, I would say, cargo transportation. I will just give you some examples of use space services adapted to UAM. We want to work on pre-departure flight plans, scheduled time of arrival slots, airspace constraint, vertiport information. We want to simulate what could happen on an airport with manned aviation and with one vertiport. Of course, I already told that we are going to work on this airspace management in order to create use space volumes. Today, these volumes are going to be used to segregate manned and unmanned aviation. So we will dynamically reconfigure them in order to facilitate the traffic for drones, but also for manned aviation. We will have some adapted CNS, communication, navigation, surveillance infrastructure, because we will have some aircraft flying very low level. So we need to improve the system we have today. We are going also to develop a collaborative interface with ATC, in particular for the approach phase at the vertiport at Pontoise Airport. We will develop all the operational procedure, takeoff, landing, departure, arrival, approach, holding patterns, surface operation. We will simulate maintenance, recharging, boarding, disembarkation of passengers, and so on. And of course, we will also tackle emergency landing situation, and we will see how it is possible to have the ATC, which is a manned system, and the use space being able to develop mitigation procedure, for example, by clearing the required airspace and making appropriate reroutings. And this is just the beginning of the story. We will have to develop a lot of other procedures. So in conclusion, we are going to continue to work on the regulation, and we think this is something very important. Of course, we want to contribute at European level in order to develop the future of UAM. But we still have a lot of open questions on society perception, society acceptation. We also have questions about the competitiveness of the actors. We have questions of the risk related to drone activity, to all the threats. So we still need to work all together, regulators, air navigation service provider, industrial people, in order to build something consistent for urban air mobility. Thank you for your attention, and please don't hesitate to send me an email. Thanks a lot.
Thank you for your presentation and the survey of your activity there in France, working in drones and urban air mobility. It was very interesting. Thank you. So to finalize our survey today, I'd like to turn to South Africa and introduce Keith Malejo. Keith is a testing standards officer for air traffic services at the South African Civil Aviation Authority. Keith, over to you. We look forward to your presentation.
Sorry about that. I was just meeting. Am I audible to everyone?
Yes, we can hear you, and the presentation looks great.
All right, thank you. So first of all, thank you to NASA for actually affording us the time and space to actually present our state's efforts towards UAM, and as others know it as advanced air mobility. So my presentation will start shortly by an introduction and our current work as a country, and then I'll briefly look at the efforts that we are putting in towards the UAM or advanced air mobility, and then swiftly move to South Africa's plan, and in concluding, I'll then state my personal perspective and how we should go on about it. So as we all know that aviation is made possible through a system called air traffic management, and so far the system has performed magnificently. But we know, given this time and period, of great innovation and technology, no business or organization would succeed without actually putting forth and putting in front innovation and technology. And we are at that period. It is very much inevitable that autonomy will then, or maybe has then prevailed, and is currently dominating, and in the future will continue to do so. And from the UTM market, it was estimated that the drone industry would then have a compounded annual growth rate of about just under 2 million by the year 2025. So the greatest questions for CAAs, NSPs, airports, governments, and far-reaching aviation enthusiasts is how do we then protect our interests with such figures? Obviously, I'm sure everybody can pick up in the undertones that I'm from the regulatory. Of course, I'll look at safety and security while also implementing and promoting great aviation innovation. So the current work at the CAA, it's funny that your event actually coincides with what we, as a state, have termed the National Civil Aviation Policy Review. So last year, in about November or so, the Department of Transport in South Africa then sanctioned a group of experts to actually review the policy. And in the policy, for the first time since 2015, we then established a chamber that would then talk to technology development and advancement in aviation. And as you know, I'm not sure for other countries, but as for South Africa's perspective, is that we are directed from policies, and then from policies we'll then start to compose or make up civil aviation regulations and civil standards. And what then has happened so far is that this policy review committee, the technology one, then designed a full value chain, which then looks at design and development of technology that is RPAS, UTM, and so forth. Where in the design and development will then look at research and design, prototyping, process development, and regulatory approvals and sales. And then in the next chain, within the value chain, we look at the assembly and production, which checks out component manufacturing, because we want to try as much as being inclusive, but also check what the world is doing when it comes to component manufacturing, software development, assembly and testing, certification. And then from there, we'll then move to the applications of these technologies, such as your military usage. I know for the greatest time that military has been using drones, but now it has become more of a civilian application, and obviously the military will then look forward to advancing the current stance. Logistics, agriculture, and mining, given South Africa's history in mining, entertainment, insurance, and energy. And then we'll look at the pilot operations, which is then RPAS pilot training and RPAS certification and operators. And then lastly, we look at maintenance and insurance. With this, what then happens is that once you have established the groundworks of such a value chain, you open up doors for technology advancement. And then from there on, you can start talking about the likes of a UTM, and advanced air mobility, looking at aerotropolis and so forth. So the current picture with advanced air mobility in South Africa is that we do have quite a number of BVLOS operations. South Africa first established its RPAS regulations in 2015, which many other countries in the world then took some pages out of them, and then they led with it. But then what has happened with that is that we then remained behind and became a bit stagnant in our progress. And then other countries then led with it, and they, as we can see, they're very far in the establishment of a advanced air mobility. But what is happening is that when we then come back to South Africa, we look at what we have done in terms of BVLOS operations. We then get to see that we are actually still on par with the other countries. And in the current ATM situation or picture is that airfares that operate commercially are then accommodated in the conventional airspace through what we call flexible usage of airspace, which is then commanded by the Central Airspace Management Unit that is run by the NSP. What is then planned after we made few revelations yesterday in the aviation policy review. We then decided that we're gonna go for Aerotropolis, setting up special economic zones. We then moving forward with the debate of IPS, ATM integration versus UTM. Obviously, both of these things have their own limitations. For one, I can tell you about a UTM. We're looking at about 400 feet. And with the growth rate that IPS is being seen at the moment, will the UTM be enough? So why not just integrate it into what is already been established? So we argue in those cases, special economic zones, it's literally advanced air mobility, where everything is advanced in terms of technology, and we're pushing forth and promoting innovation. And Aerotropolis will be cities or metropolitans to actually accommodate such projects, to say for now. So South Africa's plan since the inception of the new policy review was to have a broad stakeholder consultation and industry consultation. A broad stakeholder consultation would then be government departments, from the Department of Transport, moving right to the Department of Trade and Industry, your safety and security cluster. That will all be the state entities, and then the industry was what we had yesterday, where we actually invite the industry to actually table the work that we've done or established as a policy so far. And then from there on, we'll then move to drafting up of a strategy and implement our strategy, and then watch how our strategy performs, seek for continuous improvement, and so forth. So in closing, this is my personal perspective of how things should be. I always ride around with the word or term of 3 C's, which is collaboration, cooperation, and co-creation. Co-creation being very central to all of it. So collaboration is us literally combining efforts and saying, look, this is what I've done as a defense state. This is what I've done as NASA. How far are you guys? And this is exactly what NASA is doing at the moment, is asking how far are you guys? Where can we help? Can we establish any partnerships? And then cooperation, once that partnership has been established, it's literally for us to look at the picture with one eye. Obviously, there'd be differences and so forth, but still keeping the main picture the main picture. Co-creation is us being together and creating something wonderful. And that's it from my side. Thank you very much.
Well, Keith, thank you so much. That was an excellent survey of the UAM and UTM work there in South Africa. Very much appreciated. And thanks again to all of the presenters. In this session, I was struck by the commonality of programs, projects, approaches, but also the unique circumstances that each of the presenters described unique to their countries and their regions. And it really, I think, provides an interesting opportunity for work together going forward. So this completes this session. We have scheduled a 10-minute break. It's an opportunity where passengers are invited to get up and move about the cabin. We're a little bit behind schedule, so we will take a 5-minute break, and we'll be back online here shortly. We'll take this opportunity to welcome participants back to the next session of our AAM International Day, or as we've crossed the date line in some countries, maybe we should call it our AAM International Days. The next session is a panel on international standards and harmonization, and reintroduce Davis Hackenberg, who is NASA's Advanced Air Mobility Mission Manager, who will lead this panel discussion. Davis, I'll turn it over to you.
Thanks, Justin. I'm sure there's some first in there for me, where being on a meeting that spanned 2 days continuously. I'm not sure exactly what the first is, but there's something in there. If I could, please have all the panelists turn on your cameras, and you don't have to unmute yet, but I just want to make sure we have the group out there that'll be participating in this panel. So if you can start doing that, please, that'd be great. And then just as a quick overview of what we're going to do, 3 to 5-ish minutes for each of our panelists. I'm just going to go down through each of the panelists, and they're going to just do an introduction to themselves, talk a little bit about the organization they represent and their priorities. And then there's a list of a few other things that we're going to try to cover over the course of the panel, some of which will be covered in their opening remarks, and others we'll cover in discussion on the back end. And those things include recommendations for international harmonization, some opportunities for joint goals and how we accomplish them, kind of an approach to global requirements, and then any gaps they currently see out there. So I don't see many of the panelists with their cameras on now, but that could just be my Teams or something. So I don't know, Anna, if you can verify that we have our panelists out there and that people are.
They are correct, Davis. They are all in the room, but they have not turned on their cameras yet. I believe they're going to do that in their introductions.
Okay, great. So we'll start with Robert Bouza then from the FAA, close to home, but he's first on my list. So like I said, for the panelists, I'm just going to go down through the agenda list so that you can know if you're coming next. So Robert, do you mind a quick introduction? Talk about some of your organizational goals and priorities and such.
Robert, you're on mute, please.
One more shot, Robert, and then I'll move down and move you either to the next or the end of the list.
And Robert, if you are struggling to get off mute, feel free to exit and re-enter the room. Sometimes it'll reset your microphone. Sorry for that hiccup.
Sure, and just to add, please post questions during this. I'll be monitoring them as well, and since it's discussion, I can react real time to some of the questions if there's anything specific. Okay, so since we're not able to get you right now, Robert, let's start with Ruby Saeed from IATA.
Thank you, Davis, and thanks for the invitation to be today with all the great speakers in this panel and also in the previous session. I work at the International Air Transport Association, IATA, and with that we represent the airline industry and commercial aviation traffic. And as PK mentioned, there's a great benefit and value that aviation brings in terms of connecting people, cities, and enabling global trade. And today we see ourselves at the cusp of bringing more and more innovation to the public. And this was highlighted in many of the presentations in terms of the growing demand for urban and advanced air mobility. And perhaps the new norms that we are living in today have even maybe amplified those demands and created more and more reasons and motivations for transformations in society, as PK put it. So in addition to the aircraft operating for urban air mobility or unmanned air mobility, you had that slide that showed the different evolving and new airspace users. And this is causing us as an industry, or motivating us as an industry, to look at how automation and digital applications are going to transform air transportation. And in one of the slides earlier, there was this reference to end-to-end air transportation, and this also not only means that there will be transformations, but also we will need closer partnerships for the intermodality of transportation. And with that, at IATA, we have different work areas looking at how innovation and technology will ensure safety, efficiency, and sustainability of air transport. And I want to mention three main factors which are aligned with many of the presentations that we heard so far. So the first one is the traffic management architecture that you mentioned in your presentation. And we are looking at the technological advancements in ground systems and also onboard aircraft, and how that is going to change the role of the human in the loop. And what does that mean in terms of the key assumptions around traffic management? And within that context, we have been working within an industry group, and actually PK is a member of that group, looking at gaps in terms of the technology and existing assumptions specific to flight rules, and then what can we derive from that, and how can we what would be the solution for the future? Is it an augmentation of existing flight rules? Is it something new? This is still a discussion that we are having with ICAO. Another vector that was also a common theme in the presentations today is noise. And there's also work that was initiated under ICAO as well to look at noise and environmental impacts of unmanned aircraft, but also for urban air mobility and advanced air mobility. And there are different elements here that are being considered. One is the type of noise, and the other one is the impact of perceived noise. And this will be an ongoing conversation. And with that, we realize that we need to talk to a lot of research entities and agencies and talk to operators, because there are many unknowns today, and it is only with the partnerships that was mentioned in many presentations that we can look at the what will be the future requirements. The most important vector is safety, of course, and safety is fundamental for the sustainability of future operations, but also for the viability of business. And with that, we are trying to bring together different players to arrive at that balance between safety and safeguards and innovation and technology. And we see that there's a great value in learning from the demonstrations, the trials, and the projects, and having a bottom-up approach as in addition to the global consensus that we need under the umbrella of ICAO to push it top-down. So we need to meet in the middle, and that will also enable us to move at a faster pace in terms of the regulatory framework. As we saw in some of the presentations, some of the timelines for the project is 2023 and 2024, which is right around the corner. So with that, I would like to underline the value of partnerships, but also new partnerships. We have a history of innovation in aviation. We are dealing right now with more and more innovation and technological advancements, and for us to share the airspace, we need to build this ecosystem together. And I look forward to furthering the conversation within the panel. Thank you.
Great, thank you, Ruby. And I think I saw Robert Boozer come back online here. We just readmitted him, so why don't we give you another shot here real quick to see if you can get audio and camera going.
Sure, Davis, can you hear me now?
Yes, hear you and see you.
Okay, fantastic.
We can
Okay,
hear you,
well,
Robert.
good morning, good afternoon, good evening, everyone, depending where you are in the world. Glad you can finally hear me now, and I'm so pleased to be here today to discuss advanced air mobility, particularly as it pertains to harmonization of standards with you. This is really a topic that I'm personally very excited to talk about, since within the FAA's Aircraft Certification Service, I'm the manager for the recently formed Consensus Standards Management Branch that is responsible for facilitating the development and utilization of voluntary consensus and international standards. From our perspective, we view standards as an integral piece of our certification system. In the certification system, we are seeking to use performance-based rules and policies to provide the flexibility necessary to introduce new and innovative technologies into transportation systems to improve safety and performance. I would say most notably and directly related to AAM, we have moved towards performance-based regulations in Part 23 under Amendment 64, which has led to many of the new and innovative VTOL and eVTOL aircraft designs that are being proposed today to support AAM operations. To supplement these performance-based rules, standards, I believe, play a critical role as a means of regulatory compliance to demonstrate the safety and performance objectives are met. When it comes to harmonization of standards with our International Civil Aviation Authority partners, this is an extremely important aspect. I believe if we're effectively able to harmonize and recognize common standards in each of our systems, it will dramatically support and significantly simplify global certification and validation activities. From an organizational standpoint, the Aircraft Certification Service recently went through an internal reorganization with a number of changes aimed to increase our agility in order to respond to new and innovative products. Among these organizational changes, as I previously mentioned, we established the new Consensus Standards Management branch. And by doing so, I believe this really gives you a strong indication of the value and importance that we see in ensuring that we are proactively supporting the development, harmonization, and ultimately the acceptance of global standards to safely adopt new technologies into operation. Thank you.
Excellent, thank you. Sorry about that, a little slow to the mute button there. Going to move on to Leslie Carey from ICAO, please.
Hi, everyone. And same thing, good afternoon, good evening, good morning for those of you that still have a little bit of morning left on the West Coast. So as indicated, I work at ICAO, the International Civil Aviation Organization. And to give a little background on that first, we are part of the United Nations organization, and our role is to provide the forum for international civil aviation development. We have we bring together all the member states of ICAO. There are 193 member states. So these are the national governments that come together along with partners from industry and the industry associations such as IATA. They come to ICAO to agree on what the international standards should be on safety, security, sustainability of international civil aviation. Now, these standards, generally speaking, also form the basis of regional and national regulations for operations that will not cross international borders. So the role of ICAO is to provide the forum to bring everybody together and to reach agreement on the standards. Now, just earlier this week, on Monday, the Council of ICAO adopted airworthiness standards for remotely piloted aircraft, including remotely piloted airplanes, helicopters, and the remote pilot stations that they're operated from. So these standards, within a few months, will be out for international global application. They will form the basis that much of the urban air mobility, advanced air mobility, airworthiness requirements will eventually be based upon. That'll be another layer that we do coming up in the future. So we have airworthiness, we have C2 Link that has come out in conjunction with the airworthiness standards. We have flight operations and RPAS operator certification requirements that are still in the development process, but that are reaching maturity. These will all be coming out over the next 2 to 3 years for global applicability in 2026. Now, 2026 seems like a long way off, but considering the fact that it's taken us more than a decade to get to the point where we had mature standards that everybody could agree to be adopted as of Monday. So this was a huge step forward in this overall process. And we have a tremendous number of partners in the activity. So just within this panel, most of the people that are in this panel, if not participating with the ICAO activities directly, their colleagues from their organizations or governments are participating. So we have a long way to go still, but we're making a huge amount of progress on the global scale. Thanks.
Awesome. Thanks, Leslie, and congratulations on that milestone too, by the way. Okay, moving on to Maria Ruiz from IASA, please.
Thank you, David. And I want to thank NASA for organizing this International AAM Advanced Air Mobility and Urban Air Mobility Day. And thank you for inviting me, representing the European Aviation Safety Agency, to be part of this interesting panel. We, EASA, the European Aviation Safety Agency, we are a safety regulator in Europe. Some of our previous European speakers have touched upon some of the issues I wanted to talk to you about, and I will develop them a little bit further. In EASA, our main objective is to, at this point in time, in these times we are living, where the COVID crisis is affecting very much aviation industry, and where we need to have speed up the work on innovation, is to enable innovation and new operational concepts such as urban air mobility in a safe and efficient manner. Our priorities for urban air mobility are given by the industry and those stakeholders that you have heard before from Christian and from Catherine, which are working on more than 100 projects across the EU, which are implementing in various maturity, which are demonstrating implementing urban air mobility applications. So we try to work on developing performance-based regulation, that Robert was mentioning. We have already the set of regulations for UAS operation in the open and specific category. Being performance-based regulations, we need a lot of industry standards, and we are very thankful for the work done by all standardization organizations such as EuroCAI, ASTM, RTA, and we have a coordination standardization group that actually try to see how we can use these standards to meet the objectives of the regulation. We are now working on a concept of operations, an operational concept, to how we go further to complement those pieces of regulation. One of them is the US-based regulation, which, as Catherine was saying, received a positive vote by the European member states last week, and we are very happy with this. That gives a lot of opportunities for urban air mobility. And we are working further to complement those pieces of legislation to allow urban air mobility operations in a regular basis. These operational concepts, which have 3 use cases, so 3 operations type 1, which is IFR, UAS operations in control aerospace, cargo operations for control aerodrome to control aerodrome, operations type 2, which is UAS cargo operations, and UAS operations transporting passengers in a US-based environment, and UAS operation type 3, which is the pilot VTOL, which will operate in US-based environment, but also outside US-based environment. We try to have these 3 types of operations and 3 use cases based on what the industry needs and based on what we are asked by all these projects to try to allow these regular UAM operations in a time frame from 2023-2024 onwards. In addition to that, we are at the moment in the process of finalizing a societal acceptance study for urban air mobility, because we prioritize safety, visual pollution, and security concerns. What do they want to assess these vehicles, being as safe as being in a bicycle, or being as safe as being in an A320 flying from Barcelona to Cologne? So this is, we need to understand what is the societal acceptance, and based on that, we will put, of course, the safety bar. Not that we will, based only on these study results, but it's an important piece of work because we need to listen to the public. We have conducted a lot of surveys across many cities in Europe, and we are very excited about these results. In addition to that, we have in terms of technology, we have also an artificial intelligence roadmap and many other activities that complement that. As Robert was saying, we have published a couple of years ago the special conditions for certification of VTOL aircraft, and this was the basis also for the special conditions for the small UAS light certification. Our aim is with these special conditions that they are very much based on the new CS23 standards, is to use more and more internationally harmonized, recognized standards to support the certification of these vehicles, these new vehicles, and to be able to adapt to new type of machines that may come into the market. So for us, is to our work is based on what industry need. We need to support industry stakeholders, and at the end of the day, we
Maria, can you hear us? It looks like we may be losing you on bandwidth.
Yeah, okay, so sorry about that. Looks like we might have lost Maria, but she'll be back. That happens occasionally, even in our high-tech environment of today. I guess we'll just move on to Mark, and we'll let Maria close out in the Q&A if she had anything additional to add. So Mark D'Angelo from SAE.
Thank you for this opportunity. I'm an aerospace engineer and new technology leader for SAE International. My focus areas are driving the standardization of emerging technologies, such as UAS and AAM. I coordinate AAM standards and strategy at SAE and advise AAM stakeholders. I also co-chair the Airworthiness Working Group of the ANSI UAS Standards Collaborative, and I participate on numerous standards developing committees. The NASA Transformative Vertical Flight, VFS Flight Test Council, and I speak at numerous conferences and workshops. I hold a master's degree and PhD degree in aerospace engineering. My research topics included optimal search techniques and aircraft localization without GPS, using self-reliant sensors, computer vision, and machine learning. I'm interested in both commercial and general aviation, and I hold a private pilot certificate. At SAE International, our mission is to advance the mobility knowledge and solutions for the benefit of humanity. SAE is prioritizing AAM by way of standards, committees, workshops, and events. Today, more than ever, SAE remains committed to being central to advanced air mobility. Through public and private partnerships, research and development, and collaboration among our industry partners, our priority is to provide the best solutions, unbiased technical information, and education to those involved in AAM. On a daily basis, we are working closely with NASA, FAA. Robert Buza, for example, is on our panel today, and he is on multiple SAE standards committees. EASA, Transport Canada, international CAAs, IATA, ICAO, GAMA, companies large and small, from manufacturers to operators. Everyone has an important voice, and SAE is a unique organization because it remains neutral and supports multiple mobility industries which are moving closer together, especially in urban applications. So some of our priorities also include some more specifics. So electrified propulsion, autonomy and automation, best practices for design and safety assurance, artificial intelligence, cybersecurity, fuel cells, high voltage, charging interfaces, and noise measurement are some of the key areas of standardization being developed right now on SAE committees. We are focused on aligning our efforts with research and development and also with the roadmaps we've produced with our partners. Those roadmaps include the NASA ConOps, the FAA ConOps, and the ANSI standardization roadmap for UAS, version 1 and version 2, all of which are globally recognized. So this is a big ecosystem, and there are some big issues, too large for a single corporation to solve to enable their products to their full potential. Therefore, standardization among many disparate entities is needed. For example, consider all the interfaces. You have communication, connectivity, energy transfer, cargo, passengers, human factors, automation, emergency management, security, planning, and decision making. So we thank NASA, our volunteers, our audience, and we enjoy working together.
Thank you, Mark. Then on to our last but not least panelist, Andrew Hately, and then we'll go into some Q&A. Just a quick push. Conference IO is a little light on new questions. I have my own ready for the panelists, but if you'd like, get some questions on Conference IO or in the Teams chat, and I'll try to follow them. But otherwise, on to you, Andrew.
Okay, I'll try not to be too lengthy. Introduce myself. So I work for Eurocontrol. Eurocontrol is a pan-European intergovernmental organization which provides support and services to European aviation. It was founded in the 1960s. I joined Eurocontrol a very long time ago to work on Europe's flight plan processing system. And in the last decade, I've been working as a researcher in the Eurocontrol Experimental Center, which is located just south of Paris, or the southern edge of Paris. I've done various kinds of research there, but in the past few years, I've been working on UTM, or U-Space, as we call it in Europe. And I was the technical coordinator of a project called Chorus, which wrote a ConOps for UTM in Europe. Subsequently, I've become the technical coordinator of this project, which Catherine mentioned, the Chorus XUAM, the Chorus extension for urban air mobility, which is looking at how UTM could be extended to support urban air mobility. So we're trying to understand the use cases and needs of urban air mobility, which are distinct from VFR and IFR. The project just started at the beginning of the year, and we should, in the summer of next year, do a lot of flight trials, not just around Paris, but in 6 different locations in Europe. Eurocontrol is interested in fostering consensus in Europe. We've worked for a long time in research. We're a founding member of a thing called the CESAR Joint Undertaking, which is a body which is funding and driving a lot of aviation research in Europe. I've been involved in quite a number of projects that they've organized, and the Eurocontrol activities range from exploratory research all the way to assisting deployment. And our interest in UTM and UAM is driven initially by a concern for the safety of all navigation. Eurocontrol has stakeholders with all flavors of aviation, and we first came across the drone world as something that might scare them all and worry people. So that was why we got involved. We're a safety organization. We're concerned about how this can be done in a safe and equitable and acceptable manner. So that's
Yeah, that's all really. Okay.
All right, and I'll look to you for just 1 second and see if there's any video things we need to do. I see some things about choppiness, but I generally think it's probably local too. I just look to you for guidance real quick if you want us to do something to help the meeting flow better.
Yeah, I mean, I'm still working on finding Maria, so I'm reaching out to her there. In terms of images, I'm seeing you clearly on my end, so it is a blend between the bandwidth that you are experiencing and the bandwidth our participants are experiencing. So at this point, I would say let's leave it as is. But if anyone does feel like they're not hearing well or what, feel free to turn on or off your webcams accordingly. Anyone who is out there, if you are using a organizational VPN, sometimes by going off your VPN, you'll end up having a better participation experience in the meeting. Of course, that's completely up to you. Back to you, Davis.
Thank you. Okay, so for the first kind of question to tee up and let you guys speak freely amongst yourselves, you know, just going back to the briefs we saw, I saw a lot of really synergistic things. I'm sure everybody noticed that. A lot of talk about regulatory, technology development, different types of demonstrations. I think all these organizations, standards policy, and everybody needs, and a lot of talk about roadmaps, even on this panel so far. So just kind of knowing all that and hearing it all, talk to me a little bit about, you know, the synergies and any, you know, major international efforts. Maybe start with you, Leslie, that we need to embark on to ensure that there is this synergy across all of these different activities. It looks like it, you know, pictorially on people's slides, but as far as timelines, you know, big picture standards or overall regulations and things, just have each of you speak to what we've seen and how we synthesize moving forward.
Okay, thank you. Yeah, so to start off, at ICAO, we don't have the expertise internally in terms of what the innovations are. So when we are asked by the member states or industry to start working on something, we turn around and say, great, provide us the experts, because the experts are outside, not inside. And what we look for are entities that they can be governmental, academic, industry, from wherever, that have activities underway. So what are you actually developing? And are you working, if you are from industry, are you working with your regulator? Is the regulator a partner in this activity? Same thing, academia. What is your relationship? Are you bringing forward proposals to the regulator? So collectively then, how do you move that work forward so that it's not just a standalone activity in one location, but how do we expand it into perhaps a regional or across states in different parts of the world so that we can get different perspectives on it, then bring it to ICAO and say, okay, here's what we have learned from doing all of this development work. Those lessons learned become the basis for preliminary guidance material. And we can publish guidance material and update it. There's a very long process before ICAO starts looking at developing standards. Those standards will constrain the developments rather than enable them. So we're looking at how do we facilitate, how do we enable more development, lessons learned continually coming in, increasing the guidance material until it's all mature enough for us to say, great, we're ready for standards. So this whole new field of advanced aerial mobility or urban air mobility, it has a lot of different elements that already exist or that are already being worked on. We have UAS traffic management. ICAO is very involved in developing guidance material which is based on existing best practices. And much of that material we obtain through our drone-enabled symposia, which everybody is invited to participate in. It's also based on traditional aviation, and it's based on material that we are developing related to remotely piloted aircraft systems. So we have to bring the different pieces together, see how they fit, where are the levels of maturity, and from that we can start determining what kind of path forward needs to be taken at a global level.
Feel free to jump in.
Oh, sure. So this is Mark Angelo with SAE. We have some examples we can share. So again, like the question is where are some international policies and standards harmonization being implemented in our organization? So we work hard to ensure standards groups have the right expertise to produce technically rigorous global standards best for humanity. And we work with other SDOs to avoid duplication of the effort. SAE has a huge variety of 180 plus aerospace technical committees bring together international experts, and they liaise with each other. The subject matter within the committees span everything from the raw materials all the way to the complex aerospace systems, and then from also the ground-based products to the airborne products. Because of its breadth, there are undoubtedly some topics that have slight overlap, so the committees have liaisons to share the information. Now, we also benefit from broadening the work among the SDO community. So an example of this includes the ANSI Standardization Roadmap for UAS, which is a guide for developing standards needed to support UAS spanning all sizes, complexities, and operations. The work coordinates the development of standards needed to facilitate the safe integration of UAS into the national airspace system with input from international entities like ICAO, EASA, NATO, DOD, DGCA, CAAs. And we also thank Dr. PK and his team for contributing to adding Section 8.4 for enabling AAM. So the roadmap activity brings together various standards developing organizations. The SDOs develop the standards to support the certification, and the certification authorities do the approval for enabling the new products and services into the national airspace. And here's a third example. SAE G34, Artificial Intelligence in Aviation, is a joint international committee with EuroK WG114. Another example is the S18, SAE S18 and SAE S18 UAS Autonomy Working Group, which work jointly with EuroK WG63. These groups are developing standards for UAS and AAM. SAE International has MOUs with EuroK, RTCA, ASD STAN, and is preparing one with Gamma. And we also have a long legacy of standards references to ASTM.
Mm-hmm. Yep. So thank you, Davis, and for all the speakers for their insights. I just want to also complement what Leslie was saying, because there are different platforms and avenues that ICAO makes available. One of them is drone-enabled, where industry is invited to make presentations, and actually these presentations, they're not just in the symposium, they drive many of the documents that the UAS advisory group under ICAO develops, including the ETM framework. And as I understand, and Leslie can comment on it, the UASAG is also taking a more focused, a more enhanced focus on advanced air mobility. But it doesn't take one entity to move forward into the future. It has to be a collaborative approach, and it has to be input from industry as well as from regulators. And this is why in one of our groups, which is also an example of collaboration, when we are looking at the gaps when it comes to flight rules, and Andrew mentioned the chorus work, and there's a lot of good material to make use of and leverage the work. And this is going back to PK's point, how can we leverage all the good work from these different groups, from these different entities, and then support ICAO in making sure that we are ready for the future. We need global harmonization because the industry wants to be able to operate everywhere, right? It's not just in one airport or one city. So these groups are available. It's more how to leverage them, how to connect them together. ICAO is more than collaborative and available to publish guidance material. We can work with that. There are channels to explore. It's more about how we bring everything to focus on the mission at hand, which is the future ecosystem. So that is just an additional comment about how we work, for example, from IATA side, and primarily our work is providing input to global standards because aviation works everywhere, and the same is going to apply for AAM and UAM as well. Thank you.
If I could just jump in here. There is a slightly strange situation at the moment, though, because for decades, aviation research has been involved in incremental improvements. And so the cycle of regulation and standardization has always been fairly short, and it's not been terribly difficult to put together teams of volunteers to develop standards on which regulation can be based. But for this new field of urban air mobility like UTM, we are facing a clean sheet of paper. So without the regulations in place to drive the direction of the standards work, the standards are not being produced or haven't yet been produced. And without the standards to lean on, the regulations can't be applied. So we have a bit of a problem that we need to solve at the moment in the short term to get the system kick-started. Because certainly in Europe, working with Maria, who hopefully will return, the regulation was just signed last week. As Catherine mentioned, we're in the process of writing the acceptable means of compliance for this regulation. An acceptable means of compliance almost always refers to standards. You know, the regulation can make a very short statement, such and such must work, and then the acceptable means of compliance will say what we adopt this particular standard or that standard in order to make it somehow portable, somehow implementable. And when we look around, you know, many of these standards don't currently exist. So I challenge Mark and similar organizations to hurry up and produce something because we're facing a bit of a problem here.
It'll go as fast as the industry wants it to go. We're not holding it up. They're all volunteers.
Hello.
Well, I think Andrew touched on something really key there in terms of the research element of this as well. And that's something that we actually just discussed recently with a number of the standards development organizations in terms of the direct relationship between what's needed from R&D to inform the development of new standards that enable these new type of technologies. And so that's something that I know we are actively seeking to strengthen the linkage between our understanding of the R&D that the FAA is sponsoring, that NASA is sponsoring, or other sources are sponsoring, and how that's going to fit into our standards and regulatory framework in the future. In the interim, we're continuing to work, without, a full suite of standards to accommodate this type of technology. We've got the tools to be able to do that right now, to work on a case-by-case basis, to work with applicants, and we've been coordinating with our International Civil Aviation Authority partners as we've gone through the certification processes to develop these new types of aviation vehicles.
Yeah, and we have identified where those gaps are, and we're working towards those through the channels of the ANSI UAS standards roadmap as an example, and then in Europe, the EU SCG and the rolling development plan as well.
Hello, do you hear me now? Oh.
Yes, we can hear you,
Yes.
Maria.
Okay, finally. I think it was an issue with my VPN, so I disconnected, and that's why I was lost for some time. The question was to provide some examples and where we have adopted international standards for the purpose of UAM or AAM. I would like to provide two examples that we have, but Andrew has said we will need to have more standards actually to support even these two. So for us, in the certified category, when we have developed the concept paper or our concept for how to develop the regulations, we looked at ICAO, and we have taking basically all the work that the ARPAS panel has been working on for the past decade, almost, as Leslie said. And we were based to develop our concepts. We were based on this concept layer for the ARPAS panel, for the airworthiness, but also for the development of the operation, the development of the ROC concept, the development of the remote pilot station operator, the maintenance concept. So we are working towards, based on this concept, developing the European rules. Another example, which is at the moment in European regulation, is the SORA, the standardized, the specific, operational risk assessment methodology that was developed by JARUS, so an international group, and we have adopted as a acceptable means of compliance for the regulation in the specific category of UAS operations, and is the basis for the member states in Europe to provide the operational authorization for UAS operation in the specific category. So we, to support SORA, we are also looking into all sorts of standards available everywhere that will help operators to fulfill the requirements derived from the application of the SORA for the specific application. As Andrew said, at the moment on US space, there are very few standards available, but whatever it is available, we looked into it and we see what can we take. So being the geofencing or the geo-awareness standard from EuroCAE, be the network identification from ASTM. So we look into what is available in order to see how this standard can fulfill the requirements of the regulation. As Andrew said, at the moment for the use-based regulation and the services, as Catherine was explaining, there is very little available. So we invite the standardization organizations, EuroCAE, STM, and SAE, and ISO, or everybody to work on those standards, validate them, and support the performance-based regulation.
I just wanted to pipe up on one other thing that's come up in various different ways this afternoon, or at least today in this overall session. And that comes back to terminology. So when we're talking about AAM, UAM, drones, air vehicles, aircraft systems, air systems, aerial systems, what gets lost in the process is that we have collectively an immense number of standards that all apply to aircraft. And the flying machine is an aircraft. So if we don't call it an aircraft, we are by default saying none of those standards apply, because now it's something new. And we have no regulations, no standards that pertain to that new thing. So part of the role at ICAO that we spend quite a lot of time on is trying to make sure that everything gets put into the appropriate terminology that is already established for civil aviation. Where it truly does not fit, yes, we have to come up with something new. And some of those can be quite creative. We can string a bunch of words together to come up with a new thing, whatever that thing is, such as a remote pilot as opposed to a pilot. Because legally, a pilot is on board the aircraft. If the pilot is not on board the aircraft, well, that person is something else. So we have named them and put them into standards as a remote pilot. An unmanned aircraft is a qualifier. It's like saying a cargo aircraft. Unmanned is simply the adjective associated with the fact that it is an aircraft, but unmanned or remotely piloted, or any other term that we want to put on as an adjective, is really just the qualifier on it's an aircraft, and here's a bit more description of that aircraft.
Mm-hmm.
And because it's an aircraft, all the standards apply, unless they cannot. So there are gaps, but we have to work those out. But keeping the right terminology is tremendously important to developing a regulatory framework that can be implemented, particularly on a global basis.
Absolutely, Leslie. Yeah, thanks for that point. Spot on.
So just a few more minutes. I'll pose one more kind of general set of questions for you guys to field however you'd like, and then try to move on to the general Q&A where you guys will also be available, I believe, as long as you can all stay. PK will lead that, but there's two over here in the chat that have been there for a little bit that I wanted to get to. One's directed right at you, Rob, from the FAA perspective, but I'm going to generalize it a little bit more if that's okay. So, you know, from my perspective, NASA works pretty diligently with you guys to have a research transition plan that we work through research transition teams with the FAA. A lot of our research goes into standards bodies to create standards so that we get the appropriate tech transfer and industry can leverage that research uniformly and certify, whether that be airworthiness or operational approvals or whatever the need is. I think it's going to be, I think the intent of the question is it's going to be really important for you guys from a regulatory perspective to be coordinated across the entire agency. We're challenging you a little bit to do that, I think, personally, and I think the industry would issue that same challenge. It's not just you as a regulatory agency. You could take this to any one of the panelists and you know, ACAO, EASA, whatever. But could you speak to that a little bit? And then just so that I only have to speak once here, there's the next question is about the pace. Leslie, you mentioned the 2026 and that pace. Maybe if you guys could kind of extrapolate on what you have to do with respect to your organizations to kind of get a coalition around that standards roadmap, if you will, that's developed, and then how that progresses into the pace of what ICAO and international may need to do.
So Davis, to your question and to the question posed, which I think was specific to the AUS office, we are really setting up a new framework and new operating procedures to help enable that broader conversation across the agency to ensure we're having the right level of coordination across the FAA, within aircraft certification, within aviation safety, which would include AUS, and to other lines of business as well. And so that's something that we are currently taking a very close look at, and we're seeking to identify ways to improve our communication, specifically as it relates to standards development activities. And I do know that there's also quite a bit of changes occurring pertaining to the R&D elements as well, to hopefully provide a more cohesive approach from the agency that's well coordinated. And I guess I would say specifically to the question for AUS, I just wanted to mention that we are talking with them on a regular basis, specifically with the AUS 420 Technology Programs Branch. We meet with them regularly and are having discussions with them about how we can prioritize the standards development activities that aircraft certification things we need to engage in, and making sure that's aligning across AVS with the AUS office to ensure that we are in unison in terms of our approach for how we want to support the development of standards that we deem to be of a higher priority.
All right, and then getting into timelines. That's kind of a touchy subject for some of us at ICAO. So the development of standards that are done at the ICAO level, that is always a very lengthy process. The rulemaking process itself is, generally speaking, about 2 years. But to develop a mature proposal is where it can take multiple years. So getting to the point where we had airworthiness standards that were appropriate for remotely piloted airplanes and remotely piloted helicopters, that were sufficiently consistent with conventional aircraft standards, took a lot of work. So that there were multiple years involved in all of that. Going forward, we have the operations requirements, flight operations, which includes the RPAS operator certification process, all the air traffic management related standards, detect and avoid. We have a lot more work to do still on C2 links. Just trying to look through some of my notes here. There will be standards, additional standards on aviation security, environment for both noise and gaseous emissions, facilitation of aircraft as well as cargo that cross international borders. These will all take time. We are trying to replicate the entire manned aviation regulatory system in just a few years. It's taken 75 years for manned aviation to get where it is. We have a lot to try and catch up. But also, it's very important for everybody involved in this whole industry to understand that at ICAO, this is a small side activity that comes with no funding. So we are effectively trying to do this work from the Secretariat perspective in our spare time. This is not there's not a large team moving this work forward. And in fact, as we try to move things forward, we are taking away from manned aviation requirements. So all those incremental updates that are necessary to keep manned aviation on track, we're trying to steal that away from them. So this is it's a bit touchy at ICAO in terms of how much we can do and what the resultant timelines are. We've had to slow things down because we simply don't have the resources to do the work. And the states, the civil aviation authorities, have indicated they don't have the resources themselves to keep up with the change of pace of ICAO standards. So we are really quite hamstrung with the timelines, and that's something that we just simply have to live with.
So I will jump in. I can't see Davis anymore, so I don't know if we lost him or something. But oh, there you are, Davis. So
I had a 5-year-old come home from school.
Oh, okay. Sorry about that. I just thought Teams was playing some game with me because Teams was not reliable this week, at least for me. So just on that, and Leslie, understanding all the requirements and the process within ICAO is designed for a purpose, because air transportation, especially when we talk about the air transportation of people, the safety levels are critical, not just from aviation side, but even from the flying public side. But as we move into the future, we recognize even within IATA that we need to think a little bit differently about how we develop standards and how we arrive without compromising the quality control process, but how can we use the trials, the demonstrations to learn from them. And then, as I mentioned before, I think this bottom-up approach would be critical as we move forward. And you know, we have maybe a margin for flexibility that might not be huge, but there is that margin for flexibility. So how can we be flexible and where? And then do we need structure, and to what extent the structure needs to be available? And this is where, you know, it's triggering the industry to think differently. And we want to work with the new players in the airspace. At the end of the day, the airspace is a finite resource. We all have to share it. So how do we share it in a safe and efficient manner? And there are a lot of questions that are unanswered today, but we can address them together. And this is why we feel that we cannot be, you know, this is our area and this is your area. It's not a segregation that will be sustainable in the longer term. It's only through collaboration, and we need this information, lessons learned from the trials, from the demonstrations. Thank you.
Yeah, so I just want to say there seems to be a little bit of confusion from the audience coming through in the chat window. So I just want to offer just like some background perspective, and to add to what Ruby said about you know, bottom-up approach with standards. You know, ICAO is at a very, very high level global regulatory level, but much of this is going to come up from industry itself, and industry is going to drive it. And in the United States, we have a legal precedent for that. So first, to give you some background, much of the policy will be informed by industry standards efforts. In the United States, the National Technology Transfer and Advancement Act of 1995 and the corresponding OMB Circular A119 revisions state that all federal agencies must use voluntary consensus standards in lieu of government unique standards in their procurement and regulatory activities, except where inconsistent with law or otherwise impractical. Now, we also, now you fast forward a little bit, we witness the transition from prescriptive aviation regulations to performance-based regulations around the world. When accepted by a regulatory authority, industry consensus standards offer a vetted and trusted means of compliance to the regulations and policy. And as an additional benefit, the industry standards are maintained by the public and private collaboration with subject matter experts, that is the industry, for example. And the development of those standards are in an open and transparent process and framework, and they remain flexible and timely to the rapid pace of technology advancements. So I just wanted to clarify that with our audience today, that, you know, industry is a driving force of this, and the standards will be developed as fast as you want them to be, as fast as industry wants them. At SAU, we could publish a standard within 60 days. I mean, you have the 28-day ballot process at the committee level and the 28-day ballot process at the Aerospace Council level, and then it's published, you know, when it meets those approvals by you. So I just want to point that out, that, you know, there's no artificial roadblocks that are slowing it down. This can happen as fast as you want it to happen. Now, there's obviously a lot of work that needs to be done. So, you know, we've identified a lot of the gaps in the roadmaps. Again, I'll say the ANSI standardization roadmap, the UAS, the NASA UAM ConOps, FAA UAM ConOps, and also the work plan on the standards committees themselves. We identify gaps such as like avionics and navigation, spectrum, automation, software considerations, cyber physical security, cyber physical system security, high voltage, electrified propulsion, AI, noise measurement, human factors, maintenance, electronic transactions, traffic management, you know, especially when you get up to the higher UAM maturity levels, and design and operation of aerodrome facilities. And, you know, critically, government and industry, including research, work together in collaborative environments to ensure the path forwards. And standards are a very important key to achieving the success of the AAM vision. And again, I just want to reemphasize that collaboration is important, and it's necessary to develop that roadmap and to agree on the responsibilities and expectations of all those involved. And I guess I'll just say that, you know, we have, and thankfully over the many years of aerospace engineering and aviation, we have many best practices and systems engineering approaches, which can be applied to NASA's AAM pillars, the cross-cutting barriers that were identified, and entities like SAE and NASA and the other SDOs have strengths in convening global stakeholders together as often as fast as industry desires. Thank you.
So I'm gonna take this opportunity to get PK back on here and kind of, since we're in his time slot here now, let him make determinations as to where he wants to go. There's a few relevant questions probably remaining in the MS Teams chat, and then some other stuff over in Conference IO, but I know he's been prepping for this Q&A session as we've talked here, so I want to make sure he comes online, PK, if you're ready, and then I'll leave it up to you to facilitate. I'm ready. Yeah, sure. So we can, you know, this group can go.
First of all,
go from there. Yeah. Thanks. I can't see you yet,
thank you,
though.
Davis. Yeah. Oh, you can't. I'm on. I can see myself. Can you hear me?
You know, yeah.
We
Sorry.
can hear you nice and clear, PK.
We can see you and we could hear you, PK.
Can you see me and hear me?
Yeah. All good.
Yes,
Okay.
Dr. PK,
Yes.
we can see you and hear you.
All right. Okay. So first of all, thank you everyone for a wonderful, basically international forum. This is the first time we tried this. Last year we wanted to do this in person. It's almost a year ago, to believe it or not. So we are getting together now finally, and we are going to make a habit of this. To be honest with you, when Davis and I cooked up this idea of doing this international thing, we didn't know how well this was going to be, and it's actually surpassed my expectations, and it's brought much needed dialogue together that hasn't happened and starts to basically happen together about different experiments and different programs that are going across the globe. Also, getting the reality dose is a good idea. You know, we need to understand the challenges that it is going to take. Obviously, we are all enthusiastic about it. The future is very interesting and exciting towards aviation, but at the same time, there is a rigor that is involved in aviation. This is not a, you know, sort of a Toy Story movie 3. This is a real substantive, basically ecosystem that we are building, one that has significant ramifications on economy and safety, and we take that seriously. So this was very clear today in terms of number of initiatives that are trying to get to the right type of detail and rigor and the risk-based approach to getting there. So while we all share the excitement about future, we are trying to get there closely. Now, there were a couple of comments as to say, like, can we just go towards AAM, move fast and go towards AAM? Well, yes, everybody would like to get there, but we cannot ignore the current users of airspace. We cannot ignore the current air transportation system, and we have to evolve with them. There's a lot of, I mean, I like to say that, and there is a lot of push. You know, a lot of countries knowingly, unknowingly say they want to be the leaders, they want to be the first ones, and I try not to fall for that hype of being the first country or the first one. There is certainly there are times when you can claim first mover advantage, but there is a first damage or disadvantage, and a significant one. And we do not want to fall for the first damage or disadvantage. Neither do we want to be dinosaurs. They were before us and then they're extinct. We need to be sustainable aviation. So I think the key there is to do this in a way that is right and sustainable. And that's the challenge that we all have. And I kind of jokingly say this, that NASA is too slow for industry and too fast for FAA. Some of you can resonate with that. And I think that's the kind of tricky balance. You know, we need to make sure that the regulatory aspects are weighted into public good, and then the the business side of the aspects are weighted into societal good, and they two meet together. I'm not saying the regulatory is not looking after societal good. They all basically have the common approach, but we do find it challenging, and Leslie made that very clear that we need to make sure that these standards are done, and Mark is basically saying the same thing. Eurocontrol is saying the same thing. So now let me just ask one thing. If we want to get to that 2025 vision where there will be some vehicles ready, some Euro K and FAA would probably certify a few things anticipated without. So what would be that first crawl space that we all want to see happen? Are we going to, let's say, where do we need the harmonization right for the first baby step? Let's not even talk about the mature step where there will be 10,000 vehicles flying. That state is coming sometime later. I may have few more gray hair by then, but let's just say that few more years, what would be the first baby steps of harmonization we all need to focus on? Let's channel all our energies into at least making something that's very tangible to get to the first step of daily use operations, even though they are 5 a day, 10 a day. What anybody wants to take that on. So in terms of safety, it could be airspace integration, it could be supply chain, it could be whatever aspects that you care deeply about, or roles, responsibilities, or maybe just through 2 or 3 critical standards. I mean, there is a standard list that we all identified. Maybe there are 3 critical standards that first need to be sorted out. So we all channel those into saying, let's get those done. What are the first 3 things that we need to have that done? Anybody wants to sort of like offer their personal perspectives on that? I have my own opinions, but I would like to get you all's thinking about it.
Well, I can definitely, chime in and provide some important standards that are in support of, supporting certification aspects. One of which I would say is AIR 7121, which is developed by S18 UAS Autonomy Working Group. That document deals with identifying, applicability of existing development assurance and system safety practices to these types of vehicles, such as unmanned aircraft systems and eVTOLs or VTOLs. So, for those of you who may not know, there are these couple safety design assurance and safety assessment standards that are accepted as means of compliance that are used for Part 23 airplanes, Part 25 airplanes, Part 27 rotorcraft, Part 29 rotorcraft, and those ARPs are ARP 4754, which is the design assurance, and the ARP 4761, which is the safety assessment. And this new document that's being worked on right now, this AIR 7121, is examining the applicability of those ARPs to these new types of aircraft and would identify any shortcomings and recommended practices in regards to the specific technical aspects needed for UAS development. I would also say that there is an emphasis around artificial intelligence as well. We have a committee that's over 500 people strong and counting, a joint international committee, G34, and EuroK WG114. And they have 4 works in progress right now. The main one being a process standard for the development and certification and approval of aeronautical safety related products implementing AI. So, AI is a feature that will be integrated in aircraft, not only aircraft and airborne systems, but also the air traffic systems, the ground-based systems. Then you also have we also have some standards we're working on with the charging requirements and the connectors, for these aircraft, and then high voltage. Many of these aircraft are going all electric, and they're using really, really high voltages, which we haven't traditionally used in aviation. So there are a lot of specific safety implications around that, like partial discharge, the wiring and insulation. And then there's also the fuel cells and the alternative energy sources as well. Those are all, we have recommended practices on the safe store of hydrogen fuel cells and integrating that into aircraft. Cybersecurity is another one. Electronic transactions is another one. There's a lot, if any of you are familiar with all the hype around blockchain right now, there's a ton of hype around that, and it's being used today, and we're seeing where can we put that in aviation, and how will that fit in aviation, and how will that add value and security as well. So these are all like things that are happening right now, and these are documents being worked on right now. I can actually show you there is text on a document, and these are being drafted. So I would say that those are some of the things that are in the right here, right now kind of space.
Okay, that's good. So let me then, that's really good. That and I will let's make a list of those, and we'll make that available through our website too, to say here are the things that people need to look at. So if I may ask a question to Robert and Maria from the FAA and EASA, is there a agreed upon approach for certification of these on the both sides of the pond, that there is a consistency in the way they are approaching, whether it's Part 91, Part 135, or equivalent on the other side, or some other means? Do we have any thoughts on that you would like to reflect, that there is a consistency, or maybe there could be some subtle differences in the way those things are approached because they're still in the early stages? And any perspectives on that from the FAA and EASA?
Robert, you want to start, or shall I start?
If you'd like to start, please go ahead.
Okay. So I give it a start and you complement. So this is a very important and valid question. And I am not part of the certification directorate. I am as a drones program manager, part of the executive directorate, but I am of course very involved with the colleagues from the certification directorate. So we have a bilateral agreement. UAS are aircraft, and aircraft are covered in the bilateral agreement. So this is to start with. Now, of course, the devil is here on the details, because we have, in Europe, we have the special conditions for VTOLs. We have now the special conditions for UAS light, but we try to look each other how we are certifying, and there is a lot of discussions on with the certification teams, with the experts working from EASA and from and with the FAA, because we have industry who are certifying either in one side or another, and they want to validate those products. So so there is a lot of discussions to try to harmonize the way how to certify. There is still a lot of discussions. The devil is on the details, on things like you are working on this, how it is called, this reliability, and so this concept for certification of a small UAS, we have that. We try to get this for a small UAS up to sail 3-4. We need to see how we can take on board this type of approaches, and we are really working together and discussing to have an harmonized way to certify these vehicles. Our applicants are different, their projects are different, so we need to see into this type of differences as well. So, but I think the intent is there. The teams are working on that, as far as I understand, as far as I know, and I think is work in progress. So I don't know, Robert, if you want to complement this?
Yes, no, I think that was an excellent summary, and I do know I'm glad that you mentioned the special conditions on VTOL, and on the FAA side, we haven't implemented special conditions. We're relying on the performance-based Part 23 regulations. I can tell you, I'm aware that we have been actively coordinating and continuing to coordinate with the EASA for certification activities to make sure we are trying to harmonize our approach as best as possible. I think there's some other areas too that I think that's at the part of this is at the level of the regulations or the special conditions, but I think a very important aspect for harmonization can be achieved through the standard development process by ensuring we get stakeholders from industry, FAA, EASA, other authorities involved in key standards development activities, and hopefully at the end of the day everyone's agreeable to that standard as a means of compliance, and therefore will be less likely to run into differences when it comes time for certification and validation of those products. And I also want to tip my hat to Mark for the list that he rattled off of standards. I had a list in mind, and I think he hit all of them and more. If I could maybe just add one thing for consideration for this panel, it would be to consider what we call the safety continuum as it relates to the level of rigor that are subjected to those standards for a given product and application for where it's intended to be utilized. And I think that's important to keep in mind, that not everything needs to be built to the level of rigor that we would expect for a Part 25 certificated transport aircraft.
Yeah. Thanks, Robert. I also mentioned A21 noise measurement standards too, and I'm sure I'll come up with some more.
Well, it's great that you know and you're so passionate about standards. I've never found anybody who is that passionate about standards and know by heart. So congratulations to you, Mark, for sure.
Thanks, Dr.
Yeah. So let's go to IATA a little bit. IATA, of course, serves the current community of interest with a lot of international airlines and air carriers and transport category. And now we have the new entrants. So Ruby, is there any good balancing act that organizations like IATA who have to now undertake that says, how do I represent the interest of the current ongoing users of the airspace and transport aviation, as well as the new entrants that now are vying for access and scale at a little bit rapid pace? So how do we balance those things? Are there any interesting discussions or perspectives you have? I don't like to call tension, because this is not about tension. This is about harmonizing everything. So I'd rather call it in terms of like, how do we bring this together and make it work for everyone?
Absolutely. Thank you, PK. And that's a very good question. So it's not tension because for two reasons. First of all, airspace is a shared resource, and if we want to share it, then we need to work together on how we design and structure it. Unless we're going through into the segregation, which is not the concept. We want to have accommodation and then move into integration, full integration, and to arrive at that point, we need to work together, and we recognize that, and that's why we want to work with the new entrants. And Andrew mentioned in his opening speech or his opening remarks that at first Eurocontrol's approach was, how do we keep the unauthorized drones away from airports, and that was how also our work started. But it evolved because we recognize that it's not only about that. It's not the unauthorized users. It's the corporate commercial new entrants who are going to share the airspace. And on top of that, some of the airlines are also using unmanned aircraft. You look at some of the air freight carriers; they are using unmanned aircraft for delivery, and their business models are not going to stop at just the last mile. I mean, they are expanding. I know UPS has expanded even its operation in the US, in addition to their operation in Africa with Zipline. So it is moving forward. Some of our members are also involved in discussions and conversations about advance their mobility as part of, the interface at an airport. There's an interface between a passenger taking a flight and then arriving at an airport and taking an urban air mobility aircraft, as Leslie mentioned. So this interface is important from a business perspective, but from a safety aspect and an integration aspect. And when we look at some of the announcements for vertiports, they are in very busy cities. And I'm not talking busy in terms of just traffic, they are busy in terms of airspace. So how do you integrate that scale of operation into a busy airspace where there is not only zero, it is, Leslie knows the target level of safety, which is zero is even not acceptable. It needs to be below, because there is no tolerance for incidents or accidents in the airspace, and that is why it takes a while to that. There's a huge machine working behind standards, and they are important, and we fully recognize we need to move forward, but we need to do it at the right way, because otherwise it will not be business, sustainable from a business perspective. If you have an accident, that will affect the business. So we want innovation to flourish, but we want to make sure that we do it the right way. And that's why, working with ICAO, we have these groups that are working with a lot of industry stakeholders. We are trying to do this work outside, let's say, the usual panel work, but bring it back to go into the quality control process of ICAO. We're still learning how to do it. It's not, we don't have the roadmap with all the timelines figured out, because there are a lot of unknowns. The technology is also evolving. We have to remember that. So from our side, PK, we see this as a partnership. We see this moving forward together, and we want to make it happen, but also we want it to be safe and to ensure accessibility to everyone. Thank you.
PK, you are on mute.
Yes, thank you. For other folks that are on the previous panels should also feel empowered to basically comment on it and go on the camera live here. So don't be shy. This can be a really good session here. Anybody who would like to offer perspectives will certainly come on live here. Now, and the folks that are in the audience, if they wanted to ask any questions, burning questions, they can just raise their hand here with the teams, and then we will also get to that. Let me go to Leslie and Andrew. So managing the portfolio is critical. I mean, there are current needs that are ongoing needs, like digitization and helping current industry improve some of their efficiency and safety and things like that. At the same time, you have this pull for new entrants and drones, urban air mobility, advanced air mobility, supersonic, all of those things coming in. And clearly, it's a balancing act of how do you manage the current entrants and their needs, and then enable the new entrants. So what part of portfolio, how much of the portfolio roughly you would say ICAO or Eurocontrol is distributed towards these things? Is there a sense? Is there a good balance? There's no right or wrong answer here. So you criticize for anything. You might be criticized for giving any answer here, but obviously you would be praised for giving any answer, because there is no right or wrong answer. So what is the right portfolio balance here?
Well, actually, PK, if I may, just to start off first and building on what Ruby was saying, one of the things that is really important to keep in mind is risk tolerance when we're talking about safety, or for that matter, security, the risk tolerance. If you were talking about a 10-kilo unmanned aircraft with a package, if it crashes, the consequences of that crash are probably going to be dramatically different than if it's an airliner carrying 150 people. So we cannot impose the same level of requirements on that 10-kilo drone unless it has the potential to cause similar types of consequences from an accident. So it won't be operating in the same location, hopefully. That was part of those unauthorized unmanned aircraft issue that is an ongoing problem. But if they are operating in an urban, suburban, rural environment, delivering packages, that's a totally different scenario from operating at an aerodrome with passengers and large aircraft, that if those large aircraft are impacted and they crash, we're talking just multitudes of difference. So in terms then of the scope of activity and what rightly belongs in, say, the ICAO realm versus not, to such a large extent, ICAO is not in a position to do work until the work has actually reached a certain level of maturity. There have to be flight demonstrations that have produced all sorts of results. And to have had the regulators already look at what was produced and say whether or not they support this. So bringing ICAO in too early is going to constrain industry. ICAO needs to be leveraged to start the harmonization process once there's enough material to work on as guidance, not as standards. And some of the comments that came up earlier about ICAO standards, it has to be understood that the ICAO standards are mandatory for governments to implement. You don't want governments implementing ICAO standards unless we all know that they're the right standards. So until that time, yes, the industry standards absolutely need to be developed. That is what is going to get everything moving forward. And then once that's far enough along, bring them to ICAO to say, okay, now what do we build on top of that that becomes the governmental requirement? And all these industry standards are the means of compliance. So if an aircraft is airworthy, ICAO will dictate what the process is for determining airworthiness at the top level. But how everything fits into that aircraft to make it airworthy and to make it function, those come from industry. So don't bring ICAO in until it's time for us to be involved.
Yeah, I'm so glad you clarified that, because I think a lot of folks don't quite get the perspective as to, when to bring ICAO or how ICAO influences things. So this is a really good distinction that you offered, Leslie, in the clarification, so that industry at large and organizations who are pushing the agenda, they recognize, when we get to that point. So thank you for clarifying that. Andrew, any thoughts on you from the perspective of the right portfolio balance here?
Well, this is a tricky one because Eurocontrol has different stakeholder groups who are involved and they push us in different directions. Eurocontrol is a civil military organization. So we have the military who are both wanting to operate unmanned vehicles, but they're also wanting to fly manned helicopters at very low level and things like that. So they have conflicting needs. So we end up, the main product of Eurocontrol is discussion and consensus in this area. We get involved in these technical programs because we want to be able to support our arguments, but our main activity is reconciling the needs of stakeholder groups. And how to split the effort, it comes from who makes the loudest noise, unfortunately. And we have input from GA, we have input from the sports aviation community, you know, these people who assemble bits of twig and launch themselves into the air and don't seem to mind if they crash, but they are upset if a drone comes nearby and threatens their hobby. So many different stakeholders pushing in different directions, and we're desperately trying to find consensus and a form of words in which we can sell UTM as being the solution to problems of manned aviation as well as the problems of unmanned aviation. So, yeah, balancing act, changing emphasis as it goes along. I hope that answers your point, PK.
Yeah, no, thank you for saying that. And I think that would be my last question. I'm going to wrap up here because we are almost 10 minutes over. What we're really trying to do here is, I'll summarize in one thing, one sentence, which is embracing the innovation in aviation while respecting its safety tradition. And that is a fine act to do collaboratively. I think the only way it's going to get there is collaboration through multiple stakeholders at each national level as well as internationally, and pushing the innovation at the same time, doing no harm to the current setup and system that exists, or respecting that safety tradition. It's a really balance, and we are really happy to continue to facilitate this conversation from NASA on an ongoing basis, perhaps yearly or 6 months, something to that effect, to push this kind of dialogue and get real juices. This was the very first one. We're very thankful and grateful for all of you who attended it, and particularly the panelists who offered their perspectives. And this is really well beginning. So we will continue to spearhead that. And with that, I'm going to stop here. We're, as I said, 10 minutes over by all aviation standards. We are still ending early, on time, I should say, at least. 10 minutes is within the buffer of 15 minutes. And so so thank you all. And Davis, do you want to offer anything? Davis or Justin, you want to offer any last couple of words?
Nothing here. Just thanks everybody, like you said, and especially those of you that are still up at 4 a.m. or whatever it is in your specific time zone. Looking forward to doing it again.
Okay, thank you.
Thank you to NASA. Thank you, everybody. Thank you, all the panelists and everybody.
And thanks to the audience. Bye-bye, everybody.